Well, hello, and welcome to SkyTour LiveStream for tonight, the day before Thanksgiving, isn't it? I think so. And with us tonight, as you may not expect, is Keith from P&K Space Imaging. Keith, what's up?
Ladies and gentlemen, welcome to the SkyTour LiveStream once again. I'm joining Mark. Wanted tonight to not take anything seriously, so thank you.
Yeah, one of the problems we have tonight is that our wonderful moon has decided to zip behind a few clouds. As you can see, there it is, sort of behind some clouds, which doesn't really help us too much. But you know what? We're still going to try to make it worthwhile. We're going to do a few things.
Yeah, we are.
Yeah.
We have plans.
We have plans. We have ways of making it talk.
Yeah. We don't just jump on stream and, without a plan, without a backup.
Yeah, normally we do, but still, it's okay.
Yeah. Sorry, that was a complete lie what I just said.
It's okay.
We literally organized this 10 minutes ago.
Well, yeah. Not 10 minutes ago, about an hour and a half, 2 hours ago, 3 hours ago, we talked.
Very true.
Yes. So we're waiting. You can see some clouds crossing in front of the moon there, and I'm trying to figure out what else we're going to do, what else we're going to see. But you know what? I know that we might be able to take like some...
Oh, man, that's not too bad.
Fuzzy pictures.
Yeah, it's not bad.
We'll get a few shots here. You can see the clouds moving in front. The clouds are a little bit heavy tonight, which is... They weren't here before at all, actually, and I got some really, really pretty shots. It was pretty gorgeous.
That's always how it goes, though.
Yeah, I know.
And then you just do something to get your attention for 15 minutes, and there it goes.
So this is the shot now, okay? But earlier, okay, this was the shot, okay? So it was a little cleaner, a lot crisper, and it really was nice and pretty, okay? And then, unfortunately, now we're down to something about like that. See, just a little bit, fuzzier,
But still visible.
Yeah. I want to say hello to Renee Cruz and Cypher 2. Welcome, Justin T. And we have Brandy is here as well. Gina Leone, David Byrne, and of course, Daisy and Zoe Amethyst. How are you guys the night before Thanksgiving? And we got Q, Yeah, I know. We need to get a plan. Well, the truth is...
Like Star Trek the Q?
Yes. Get off my ship, Q.
Dude, that really could be the greatest character of all time on Star Trek.
Well, I didn't like how silly and flamboyant they made him, but I thought that was, John Delancey did a good job.
Yeah, well, you knew every time it was going to be a Q episode, it was going to be a good episode.
You knew it was going to be an episode where Picard gets, belittled and...
Exactly.
Yeah. Oh, look, this isn't so hot right now. Not so bad, I guess. But still, not bad. We can deal with this for now.
Sure can.
Yeah, we're looking at the waxing gibbous moon, guys, and we're just trying to check it out tonight for a little while.
Oh, you know what I have to do? I have to put your link out on P&K's social media. I'll do that while you do what you're doing.
Okay.
Science stuff.
Do you science?
Science, bro?
I do.
How about that for a shirt, too? I was so going to do it.
Oh, that's a good shirt.
To make a shirt that says, "Do you even science, bro?"
Yeah.
But I didn't. I think somebody else had it.
I was doing my science for the last couple of weeks, that's for sure.
Yeah?
Yeah.
Having your mind blown away?
Yeah, I got asked to be a cast member of a new TV series, so I'm for a major network, and I actually agreed after going back and forth, seeing what it was about, and it turns out that they paired me up with another guy who turns out to be a very good friend of mine, and we were both surprised that the two of us were asked to work on the same show. Then there was a female lead who was actually there, who is a lead investigative type of person, and the three of us made a really, really good team, I think.
Yeah.
We investigated UFOs, we investigated paranormal stuff.
Gonna name drop or just tease us or what?
Your mic just went away.
My mic just went away.
Yeah, you got a problem with your jack or something.
No. I'm good. I'm all green on this end.
Yeah, I cannot hear you. I can hear a little bit, but...
All right, let me do something.
Don't worry, folks. Keith will be right back.
We'll get it.
We hope.
Or maybe we don't. Who knows?
What? Are you there?
Okay,
Yeah, it's all overmodulated. Something happened at your end.
got it.
So yeah, we're looking here at the waxing gibbous moon. It's getting a little bit more toward full as we speak. Astronomers hate the full moon, you know that, guys, right? Because there's a number of reasons. Because the full moon is really just, it doesn't have any contrast. It's hard to actually see anything in the full moon, you know. You don't get these gorgeous shadows like down here, you know. So I don't know. Keith, are you still there?
I don't know if that worked or not.
Yeah, it's not working. I can't hear you.
All right, I'll still work on it.
Oh, that was almost good. What happened there?
I got electrocuted.
Oh, okay. Well, whatever it is, keep electrocuting. It works. No, I'm just kidding.
I think it's the mini.
Your voice was not there.
So it's still not there now?
No, you actually you sound like you're.
Why is that?
It's like a signal issue. Yeah, there we go. So.
Breaker.
Yeah, no. Negatory. Now here's an example, guys, of how the clouds sometimes work for us. You know, sometimes the clouds act like a filter that helps soften certain noise, and the images look kind of remarkably good sometimes. You know, hey there, DPFX and Rock and how you doing? Wait a minute, Daisy and Zoe are saying they can hear you just fine. Okay, that gives me something to try here. Talk again, Keith. Are you talking? I don't hear you talking. Where is Keith? Keith, you're on mute. Unmute yourself. People say they can hear you just fine, so it might not be you. See, everybody can hear you the whole time. Hey there, Jim Kearney, how you doing? Unmute, Keith. Unmute. He put himself on mute. I don't know what he's doing. So, when he comes back, we'll figure it out. I can see that there's a problem. I'm trying to figure out what it is. Alright, well. I mean, he's still muted. So, I don't know. No, Keith's trying to figure out a problem that might actually not be his problem. Yeah, so we have a few clouds tonight, as you can see. And you can see them when we actually go up higher. Sometimes you'll actually see the clouds, but they're actually very, very fine. So it's not easy to detect them.
So I'm guessing it's not working.
Okay, so keep talking.
Yellow.
All right, go ahead, talk again. Okay, you know what? I think it's my problem. How about that?
See, Antonio, you had me freaking out over here.
Okay. Yeah. You're there.
Yeah, are we there now?
You are.
Can you hear me now?
Yeah.
Do I still sound sexy?
I cannot
just admit it. Go ahead.
Confirm nor deny whether you do or not, because I would never say such words.
Oh, say it in private.
Oh, I do not, and you know it.
All right. Okay, so that's good.
Yeah,
so we're good. Okay.
Yeah,
I was on this and I'm like, what is going on?
Yeah, it's a jack issue here, which I have since troubleshooted and now know that it was all your fault, but I'm blaming me.
Well, I seen when it first did it. I seen the Mike Hawks thing on your OBS shoot all the way into the red, and that's what got me thinking it might be you're in.
Yeah, I saw that too.
Yeah. Okay. Well, we're good now.
Yeah, we are. We are, and everybody could hear you the whole time.
Yeah.
So it was only me that could not. So I was the errant individual. Hey, Don Walker, how you doing? So yes. So
thanks for letting us know there, Don and Rockstar and whoever else was.
Tim F.
Yeah, and Kim and everybody that was, that knew what was going on.
That figured it out. Yeah.
Okay. Now, what did I miss? What were you talking about when I was away?
I actually was just talking about how pushy and how overbearing you are.
Hey. Listen, I was in college. I needed the money. What? Oh, wrong channel. My bad.
Funny guy.
Funny.
Yeah, for those who've not been here before, and there's a couple in the audience that I'm seeing here that haven't been here. This is the telescope control system over here on the left. This is me. Hello. Keith is not visible because he's not allowed to be seen in public. This is the live view. You can actually see the clouds crossing in front of the moon right here. And this is the camera control system and the observatory view down here. Okay, we also have a planetarium view, which we will bring up from time to time. And this planetarium view is one that actually shows us exactly what we're looking at. And in this case, okay, we actually have, if we zoom out a little bit, you can see that we have the moon, which is actually right next to Mars up here. So that's where we are, right there, looking at the moon. And to see what we're looking at when we look at the moon, this gives us an idea. And it kind of looks like this. All right. So the planetarium is a very good one. It actually does a nice job, shows us what we're looking at and where, and so forth. And so we also control the telescope with it. So I don't need it, but I like to use it because it's fun. All right, so there we go. And now that is how we use it. And now you can still see how the clouds are going across the front of the moon right there, little faint ones. That's actually what we're seeing there. Yeah, I know, Tim F. Here's let me give you an update on SkyTour LiveStream West. I just got back from 2 weeks of filming with a major network. We're doing it was a pilot, a 2-hour pilot, and I had yesterday through the 30th to get stuff sent out to Arizona, but it looks like COVID is once again, for the 6th time, going to prevent me from going to Arizona to do this. The observatory is built, it works, it's functional, everything works, except now I have to install the equipment, and so I have to send the equipment. That's not the problem. Sending the equipment is easy. Getting there to install it is not the easy part, apparently. And I've been trying to do this since August. It's been making me crazy, So that said, I'm pretty sure that I'll get out there the next time. I'm not excited about this. In fact, I had to stream tonight. To be honest, I had to stream tonight because I was so mad and angry that I couldn't go to Arizona to do this installation and get this equipment out there, that I had to do something to make myself feel better.
Well, I mean, you could have drove.
I could have had someone who has a truck drive.
That's true. Very true. I plead the fifth. I would have drove. You should have called me.
Well, somebody's getting a whole new trailer to drive their truck out there. Drive their truck.
Did you see that thing? Oh, it's beautiful.
Yeah.
Turned out really well.
Yeah. That's really nice. Yeah.
Yes, it is.
So you just have to, if I just want to ship all the equipment out through Keith from PK Space Imaging, what would that cost me? And how and when could you do it?
How many arms do you really need? Legs?
I'll help you do everything. But
well, here's the thing. Paul was out there.
Yeah, he was, but I wasn't in this.
Yeah, it was a whole, scheduling thing. Yeah. It depends. What is it? What are you sending out? Just the scope and stuff?
Everything you see in the inset box down there, the telescope. No dome. The building's done. I'm having the pier built out there. And Marianne Robb, wonderful Marianne Robb.
Let's make this easy. Size. Give me a size.
Size. Well, let's see.
This many feet by this many feet, and then the weight. That's all I need.
Oh. Well, then you're probably looking at 5 by 5 by 5, and that's feet.
So it's a pallet.
This would fit in a pallet. This would all fit on one pallet. Yes.
Okay.
And weight would be about, counting the pallet, maybe 500, maybe less.
Okay.
Yep.
And I'll get your price on it. Okay. It won't be much. That's not much.
Yeah, but
the thing is, I'd have to pair it with another.
You would have to have other loads that you're putting on the truck as well. I get that.
If I can get 2 good loads, since it's only a 5 by 5, I can get it out there pretty cheap. But that means I would have to somebody would have to be out there to unload it, like take it from me.
Yeah. No, of course. Now, do you have a way to get stuff off your trailer?
Well, I mean, I can just push it over the side.
No.
Okay. Well, since that won't work, then we would have to find a way, because I opted not to put the crane on this trailer, but there will be one on the next one.
Okay.
So you would need, because first of all, I don't think it probably isn't a good idea to take the whole truck and trailer all the way out in the middle of nowhere.
I don't think so. I don't think you would not be bringing it out to the desert.
Right. So I'd have to meet somebody in town or something.
Yeah.
Or somewhere.
That's
and
actually,
then just put it in their pickup truck and let them drive it the rest of the way.
That's
out.
exactly right. That's exactly right.
So yeah, we'll figure it out.
Yeah, I have no doubt at all, and I know that it wouldn't be a problem. But if you got now that we're at this point now where we just basically are on a pattern of continuous, postponements.
Yeah.
I don't have a problem now. I mean, it might as well just go however it's going to go.
Right.
And if it's going with you, I'd trust that much more than a shipping company.
Yeah, I don't blame you. I've seen what some shipping companies can do.
I have seen that.
Yeah.
When this telescope arrived at the house, actually, here, the shipping company was UPS.
Oh, yeah.
From the company that shipped it, okay. And I was coming up the driveway just as it was being delivered. And I got up here just in time to see the guy take the box on end and push it over, boom, and have it fall down.
Well, yeah, that's what kind of delivery I was talking about.
Mm-hmm.
I can kind of do a drive-by.
Yeah. And I actually cut off the truck until I could open it and check it out, make sure it wasn't broken.
Yeah, that's probably a good idea. I mean, they do so much volume and stuff that they don't really care for packages that well, per se.
Yeah,
but,
agree.
Yeah, that's what we specialize in, taking good care of freight, getting it there unharmed.
Yeah. And Q, I want to say, can we detect objects crossing the surface of the moon? Yes, we can actually watch objects pass in front of the moon. If something were to pass in front of the moon, we would see it. And you'll see it as a black dot in all likelihood, because it'll be silhouetted against the moon, and usually that's a satellite in our Earth orbit, and slowly moving across the moon. And that's the direction you'd see it go, probably. That way to the left. Right. And when we see that kind of thing, based on how long it takes to go a certain distance on the moon, which we can measure exactly how far it looks like it's traveling relative to the moon.
Math,
yeah. I have a program that I wrote that will actually be able to calculate how high the satellite is in orbit around the Earth and how fast it's moving. And then we can actually go and identify the exact satellite that we just saw. It's really kind of cool.
Hey, have you and Trimble talked about setting up your UFOTOG thing out near the observatory site?
Oh, gee, why would you ask that question?
Because I'm wondering. I have a childlike wonder.
Yeah. Well, the truth is, yes, the telescope is on a cleared 5-acre parcel that belongs to a former Lawrence Livermore scientist and a good friend of mine. And there is plenty of room to put another device out there. I mean, plenty of room. And we were thinking of that, yes. The sky is so abundantly clear. And the weird thing is, here's how it works. If you're in Phoenix or Mesa or Gilbert or up north more, like in Surprise or something like, or Wickenburg even, it could be cloudy there. But out in the desert where the observatory is, it's rarely cloudy.
Yeah, sandworms.
Sandworms, that's right. Exactly right. That's exactly what it is. It's sand. How'd you know?
Well, Beetlejuice. That's where I get all my scientific information.
Beetlejuice.
Yeah.
Well, it's gonna be a good look for me.
So I actually I looked at the there's some clouds. See that? I think I got to go a little longer to get it a little brighter. Yeah, so now you get to see the clouds. Ooh, there goes one.
Well, the reason why I asked about the UFOTOG thing is because I know you said, 10 acres? Or 5 out there?
It's a cleared 5-acre parcel. It used to be all scrub and uneven, and they just flattened it.
I know you said you wanted to kind of, because you have you were going to do 2 or 3 of them for triangulation and all that stuff?
Yeah, but those are going to be a mile apart.
That's what I was wondering. I didn't know.
The baseline's a mile.
Yeah. Right. Okay. That's what I was wondering.
We could make it at 2,000 feet or whatever, and that'll still give us some data. But we want them to be far enough apart from each other so that when we triangulate them in the sky, okay, we'll be able to get farther distance data. So if we wanted to triangulate how high a satellite is, we need to get a reading of it from this point and from this point. And if this point's a mile away and the satellite is 400 miles up, okay, well, that 1 mile gives us enough baseline to be able to detect that satellite's exact position and then calculate its speed. So it gives us another way to do that. If we don't catch it on film the way we are doing with this, we can actually do exactly that. We can just do what we have to the same way, using the 2 observations from the 2 different platters.
Right.
And there's going to be 3 of them in an equilateral triangle, so equal sides, and those equal sides are going to be like that, and they'll have 1 at each vertex.
Sweet. Let me ask you, last time you were out in Arizona, did you by chance drive out into the middle of Utah and place a monolith, or no?
I'm not going to say a word. I'm not going to take credit for or deny or no, of course I didn't. No.
Read loud and clear, buddy.
Yeah, no, I did not, actually. Hey, Amos Cardoza. Hi, welcome. I figured that monolith that was found in Utah, I think that's actually just a performance art that was left there, knowing that the Park Service does a bighorn sheep tally each year. They probably put that thing out there to see if they would get noticed, and they just sat back and waited to see who would notice it.
Well, here's the thing. On Google Earth, it wasn't there in 2013, but it was there in 2016.
Okay.
So it's been out there for a while, with a lot of people not noticing it.
Yep, and you probably saw the shadow of it on Google Earth, yeah.
Yep. So it's still pretty cool.
I think
everybody
it's great.
loves wonder in life these days. A little investigation.
Yep, I think that's really great.
Yep.
That's the coolest thing.
And they did a pretty good job on it. Looks like it might have had a plaque on it at one time with the 4 little indents in the front there, but
well, there's more than 4 little indents actually. There's actually it is riveted panels or welded panels. I don't know if it's just a sheet metal construction or a solid object. It looks like it's a sheet metal construction with some formers, and what might have been is maybe it was a project that was built incorrectly, and then they said, "What do we do with it?" I got an idea. Let's go put it in the desert. Yeah.
it's shiny.
It's shiny.
And whoever did it, I mean, it's been a good job staying nice and shiny.
Oh, it's probably stainless.
Yeah. Well, still, I mean, even with Utah, you got dust, you had summer, really dry, you're going to get some layered, dust and stuff on it, but it looked pretty good.
Well, we didn't see the top. And it wasn't, it was actually, it had some width at the top, actually.
Yeah.
And there were two 6-foot guys, one standing on one's shoulders, and he could just put his hands up over the top like this.
Yeah.
So it was 12 feet high. So you can imagine there's a lot more in the ground. So how they got this thing out there is probably by helicopter.
Yeah.
You know, a friend with a helicopter, we're going to go dump this. And then the guys in the ground said, okay, let's get down there. Let's bury this thing.
Yeah, because that entrance didn't look like it would fit a truck between those 2 points where you could back into that point. I mean, granted, you could have raked the land, on the way out with like a dragger or something, any kind of, especially if it was just dry dust. But even out there, you have some pretty thick sand, and you're going to leave some indents or some semblance of somebody being there. But then again, that was probably 3 years ago, so maybe just natural, stuff, blew it over. But still,
I think they probably just hired a helicopter. The thing is probably light, and they came out with a helicopter and maybe a few post hole diggers and dug down, found a spot where they could go down enough feet to stick it in the ground. Maybe they even mixed up concrete for all we know, and concreted the thing into the ground at a shallower level.
Oh, that'd be cool. Wouldn't it be cool if it went like 30 feet into the ground? Just to really mess with people, like just totally buried down there, concreted in, and like they'll be like, "We can't budget." It's like Thor's hammer sitting in the middle.
Yeah, can you imagine if people were to go out there and say, "All right, let's just dig this up. It's enough of a spectacle. People are coming out here. They're going to get hurt. They're going to get lost, and then they're going to die out here. So let's just dig it up." Or get that Sikorsky Sky Crane ready, and they bring it down. They go to tug it, and it doesn't budge. That'd be hilarious.
Because what's the first thing humans going to do? They're either going to climb all over it, be touching it all up with fingerprints, or they're going to pee on it. I mean, there's different things that they could do.
Or throw a bone at it, yes. Hello, Isabella Melamed. How are you? Isabella joined us.
Isabella and DPFX.
Isabella, I forget. Are you in Bulgaria? I can't remember if you're in Bulgaria. Let me know in the chat. I thought you were from Sofia, Bulgaria. Is that true? It's just something in my head that popped in. I wanted to make sure that it wasn't an aneurysm. Okay. So, yeah. I can see that we're looking at some clouds. I'm going to try one other thing here. I'm going to go back to my startup screen for a minute, guys. And I am going to do something. Okay, yes, I was correct. Good. Happy. All right, I'm going to just grab a window.
By the way, you were correct. It is Sophia.
Okay, fantastic. All right, just a second. There we go. Okay, that's what I wanted. So this is our... I guess I gotta do it this way. How does one do that?
What are you trying to do?
I'm just trying to fit this into the window.
Oh.
And have it be basically like full screen, but I can't. It doesn't want to do it. I want everybody to see what I'm doing here. I guess we can go like this, right?
Yeah.
Yeah. I mean, that'll work. Okay. And for the record, just so you know, I mean, this is the live view, so we can see that the moon has a few things like clouds passing over it. So we are looking at a view that doesn't have any clouds passing over. And for the record, I also have another screen where I am looking to actually show you what's going on, or I can see what's going on, so I'll know if something's happening. I'll be able to show you. Okay, this again, this is it's a go-to for me very often. It's the LRO Quick Map browser, all right? And if you were to look that up online, LRO, Lunar Reconnaissance Orbiter Quick Map browser, you would find that this browser allows you to view the moon, down to about a 15-foot object size. I mean, It's really cool. I'll show you what I mean. And you just use your mouse. So look up LRO Quick Map Browser, and you will be able to find this. All right, and let me.
I love that site.
It is. It's a great site. There's a lot of really cool stuff on this site. So, while we're waiting for clouds to clear and or never clear, let's do some lunar reconnaissance, shall we?
Do it.
Yeah. So we can. There's a number of things we can do. When you go to the site, you're presented with this. This is the view you see. Okay, this is what you get. Here you go. This is the whole browser window we're looking at right here. And on the left side, you see these things you can do. And if you go down, you'll see this one says Switch Projections. And that allows you to change the view, which we'll do in a second. Then we have layers. Layers are very cool because this is how you see all the things you want to see, like the Apollo landing sites, the lunar modules, the tracks the astronauts left behind, etc. Then we have a draw and a search tool, which allows us to draw lines across the lunar surface and then see a profile of how deep those craters are. So for people who say, how come the craters are all the same depth? You can draw two lines and immediately show that they're not. Okay, the lunar surface is pockmarked with craters. Some are very high. The bottoms of the craters can be very high in the air relative to the moon's, well, it doesn't have a sea level, but the mean radius, okay, is what they use, or below it. And so if it's above or below, it's shown with a positive or negative number, and it's in meters, okay? And then below that, we have settings that we can use, and we also have a full screen toggle, right? So we can do that. That won't help us here because we want to be able to see the entire screen. But using your...
Go measure Aristarchus.
What?
Let's do it.
Okay, let's do it. Okay.
Let's do it. Let's measure Aristarchus. We can show them the depth feature.
Yeah, and we want to... This here's how it works. Okay, when we come to this crater, like this is Aristarchus, okay? And if you say, how do you know it's Aristarchus? Well, what we do is we go to over here to layers, and we go down the list here, right, to overlays. We've got a whole bunch of maps and other things you can do, as well as mineral studies. But you go to overlays, and you can click nomenclature. Aha. And now we get names, all right? And we see, for instance, we can see now that we have Aristarchus right here. It says Aristarchus, and this is Herodotus. All right. Now, we're also looking at this, and you can see that when you get near the edge of the moon, the craters are going to be on edge, and you're going to say, well, how do you measure one that's like way out here? I mean, look at the data; it's all distorted and everything. Well, there is a way for that. We can fix that. All we have to do is go to Switch Projections up here, and then we pick Lunar Globe 3D. Oh, Lunar Globe 3D, huh? And when we see Lunar Globe 3D...
What is this witchcraft?
What is this witchcraft? Yes, exactly. Okay.
Yeah, this is pretty... I recommend anybody just taking a day and moseying around the moon.
Yeah, but I'll show you. So here's the lunar globe in 3D. But look what else you can do. Now we can rotate it. Ooh.
You mean you can rotate it like a globe?
Yes.
Oh my! Checkmate.
Yep. And there's Copernicus, right? Look how nice Copernicus looks. Okay.
Copernicus.
Yeah, that's Copernicus.
Yeah.
Yeah, and
those crater walls.
We can zoom in and look at the data even in more detail. And the data in this mode is actually not as good as in the other mode where you can just see it flat. That's different. Okay, but look what you can do. We can deproject it.
I think you can even orbit it, can't you?
Oh, yes, we can. We can orbit it. Dave, we select this button right here. This is fly around the selected point. What's the selected point? This one.
I made a GIF out of or GIF. Is it GIF? GIF? Whatever.
Yeah.
Of the orbit around Jackson Crater and used it as a screensaver.
Wow. That's nice, huh? Look at that. So you can see that we're slowly orbiting around Copernicus Crater. And if you want to know what it looks like if you're down on the moon, well, this is right where you are, right there. Yeah. And you can see that the data fills in with better data as you go around. And some of you are probably going, wow, I've never seen this before. That's so cool. And it is, you know. So if we come out of that orbital view, okay, right, we come back and now we're here, and let's go now and do what we were originally going to do. And that is go to Aristarchus Crater. Aristarchus is now right up in front of us here. Now we can look at it like this. We can even zoom in deeper and check it out, you know, and it's just really interesting.
Deep isn't even in the word. You can literally go spelunking.
Oh yeah.
With the audio data.
Yeah, that's true. And I will actually do that here in a moment. I will spelunk for you. Now,
Great.
Now, as we get into this data, okay, you'll see that it looks a little rough until it gets filled in with the good data. On successive passes of the Lunar Reconnaissance Orbiter, they got even better data, of course, and this is what happens. All right?
Yeah, and the good thing about the LRO2 about this site is it gets updated. When they get better images,
that's right.
It gets applied to it. So it's constantly being updated with the best images.
Look at that.
It's amazing.
So there is Aristarchus from that side, and we're going to actually just get rid of the overlay of the nomenclature because we'll come back to that. All right, let me just do this for you. We'll get rid of the names. Okay. Now, let's do this. We'll back out a bit. All right, and we're going to say draw. We're going to draw a line. Okay. We're going to draw here, start here. Okay, and move across to here. Okay, and then watch here on the left. This, and you'll notice on the screen, there is an orange ball traveling across that blue line over the crater. Okay. And that is telling you where the crater data is that we're looking at. Okay. So as we go down the wall of Aristarchus Crater, when we get to the bottom, okay, we are at minus 3,192 meters below the mean radius of the moon. Okay, but when we get up to the top, to that point right there, okay, now we are, let's see here, now we are right there. This is 416 meters at the wall's edge above the mean radius. So this crater wall drops over 3,000 feet. Isn't that incredible? 3,000 meters, I mean.
It's a hell of a pothole.
It is a heck of a pothole, yeah. Yep. All right. Now, the best use of this tool is when we are deprojected.
It's in Pennsylvania.
Huh?
It's almost the size of potholes in Pennsylvania.
I would guess it is. I'd guess it is. You want to use this when you're looking across, flat down. When you go like this, that's really, this doesn't help you to look at it like that, So we don't typically look at it like that. We like to look at it from like this perspective, so we can get the exact outline, the exact line, right? And we have they're saved, right? So you can see them. And so you wonder, how big is that peak? Well, if we drew a line straight across the peak, which I didn't, you'd see that at least where the peak is, it's minus 2,791 meters below the moon's mean radius, and then here it's minus 3,197. So you subtract these two, and it tells you how high that peak is. See?
Look at the difference between the base of the crater and the peak. It's still a pretty big distance just between those two.
Yeah, it's true. And in fact, if you notice, okay, another thing to look at is you also hear in the research the Aristarchus Plateau. What is the Aristarchus Plateau? Well, it's this area, okay, that is right here on the other side of Aristarchus. It's the plateau. This area is lower. How do we know? Let's go see.
Welcome to Papa Tom. Joining the SkyTour LiveStream live on a Tuesday night, is it?
We're gonna do this now. Okay.
I'm not track of days anymore.
So down here on this Maria, this ocean here, this lava ocean. Okay, look at on the left. Look how low it is, right? And it's getting lower. We actually didn't start as low as it gets, but it's minus 1,613 meters below the moon's mean radius. And then as that plateau rises up to a peak of about 480 meters above the mean lunar radius. Okay, so this is all a plateau here, and if you zoom in and do it again, you'll find that you can actually get a better you get an even better resolution for it. Okay, so if we do this,
and I think, don't quote me on this, but I don't think there's a limit to how much of a line you can make. So you can actually see the geology and the makeup of like mare and stuff like that, how it looks flat, but how it isn't exactly flat.
That's
I don't
correct.
Think line limit.
There is a limit, actually. The limit is the resolution is based on several tens of meters. So say you wanted to see this crater here, okay, which is actually, this is a good example because you see how it shows strips. This is really good. This is less good. This is less good, taken at a different time when there was less light. This is reasonable, probably the same as this, but in less light. And then this is least of all the best. So what happens is these are different areas, different passes of the satellite. But let's say we wanted to look from here to here. What would that show us? Okay, you can see that we actually end up with a couple of lines here. All right, so you'll see that the crater depth here, this crater depth here, is minus 1,300 and change, minus 1,363 meters below mean lunar radius. Okay, but you also have lesser quality data, and there's actually two sets of data that are being used to generate this. The reason is because we've got this pass and we have this pass. Okay, there's several data points. Now, if we were to go back and say do this, I actually don't know what this is going to produce. Let's find out. Okay, but you can see that we have a this blue line, I think, is what is that? I forget. It's the Lola data, laser orbiter, Lunar Reconnaissance orbiter laser altimetry, I believe. Lunar orbiter laser altimetry in meters, and then this one is a more detailed study, but you're getting the overlay of both studies here, and we can decide what we want to use for data. We can select the data points. I think. Let me go check here. We could select them. Yeah, and we can go by the abundances of certain things like hydrogen and other materials. We can do all this iron oxide abundance, stuff like that.
This app is pretty much a must-have for lunar research.
It's a study and a half. It's a place to study the moon beyond and then some. Let me tell you. So all of these things, I actually don't do any of these studies too much because I like to use this sparingly and create my own. I use it more for classes and so forth. I don't use it typically for a live stream. I've shown people how to use it, which I think is very important to do. People should know how to use it. Okay. The other thing is we can also, if we look at this, let's do the orthographic near side. This is the one you start with. Ta-da! There's the moon we know. The moon we know and love. Hi, Mr. Moon. How's it going? But we also, when we look at this, we see that the moon also has a far side, of course, and that far side we'd like to see, wouldn't we? So we go to this map again, and we say, let's look at the orthographic far side of the moon. All right. You'll notice a big difference. If you notice this side of the moon that we don't see, you see how many more craters there are? There's more craters on here than on the near side by far. Okay, here's the near side. Okay, and you see all these dark areas where the crust was so thin that it easily fractured and allowed lava to come flowing out onto the surface and form these gigantic seas. This is a massive impact here that caused this. Okay, same here, the Imbrium Basin, massive impact over there. So these types of impacts, okay, formed the face of the moon, okay, that we see. But on the far side, we don't have that, do we? We have one place that has the lowest part of the moon, which is down here. This is the Aiken Basin, down at the bottom of the moon here, this area. Okay? And right here, I think this is Apollo Crater, isn't it? Come on, man.
That is what crater?
Is it Apollo?
Oh, man. Really? What crater is that, Mark?
I thought it was... It's not Jackson.
No.
No, that's yours. Oppenheimer? You didn't know that. Oh, here's Apollo. See, look, there's Apollo.
See? Yeah.
You didn't even know. Why don't you give me that?
Never mistake Oppenheimer for Apollo.
Yeah. You're a funny guy. So this is the lowest spot on the moon, and oddly enough, just a little bit up north is the highest spot on the moon. And the highest spot on the moon up here in this little highland area is the result of the lowest spot's creation. When this was created, many waves, seismic waves, moved. This is a massive impact from an object that was hundreds of miles across. And in fact, on this side of the moon, our studies of under the surface show that it's still there. The object that collided with the moon is under the surface here. Okay, buried. And up here, in these waves of shock waves that moved out, actually uplifted the land hundreds and hundreds of miles away, 1,000 miles away almost, and caused the highest spot on the moon to occur up in this region. It's pretty interesting how that worked. So yeah, this is cool. And now I want to go back to the front side just because I would like to show you something else, and that is how close we can actually get. So let's pick the crater Taiko. And where's Taiko? Well, we'll show you. Hey, there's the moon.
Yeah, it doesn't look too bad.
No, we got some moon tonight.
We got some clearage.
We have a little, well, it's really not there's some high altitude clouds, but let's just try and get a photo and see if it's going to come out. I'd like to show you this. Okay.
Photographic imprint.
So this, yeah, it's not that good tonight. It's not yet. We'll wait it out. There's some clouds, but this is Taiko. Okay, Taiko Crater right there. This is familiar to most of you that know the moon because Taiko has the biggest ray structure. You can see the rays coming all the way out here, and that's something on the moon that's really cool. So when we look at Taiko over here, right, we're looking at a ray structure that goes out in all directions from the moon, and we can see them all the way out to here. See, here's a ray structure right there. Okay, that's really, extensive.
Miles.
Yeah, and then you got them here as well, and down here. Okay, and so that ray structures tell us a lot about the moon. It tells us what the angle of the impact was, for one thing. If it was all splattered evenly on all sides, then we know that the thing came down and hit almost dead on. But if it comes down at an angle, then most of the stuff gets splattered out in a forward direction. So it goes bloom, and stuff goes splattering out forward where the hit is. And that's pretty cool. But when we look at other craters, you see that the craters have rays that are very linear. They just go off in one specific direction. Those are the glancing blow ones where they actually came in and went shoot and hit like this. And you say, well, why are the craters still round? Shouldn't they be elliptical in shape? And the answer is, that's not how energy distribution works. And you go, wait, what? I can show you in a simple example why all the moon craters are generally round.
Liquefaction.
Well, kinda, actually. We go to liquid and how liquid operates to see. When you skip a stone across the water Have you ever created an elliptical skipping area? Did the circles ever come out in an ellipse from the ring where they struck? Each rock and when the rock skips, clip, skip, as it hits the surface, the rocks make round rings that come out from them. That's because even though the rock is at a low angle, when it strikes the water, there is a downward component of force that goes splash in all directions. And that's exactly why we have round craters in the moon. It's the same thing, right?
So it's kinetic energy, the impact. It turns basically our moon surface into like a watery thing.
Yeah, actually, for big impacts, okay, that is true. And I'll give you an example. If we look here you're smart. The picture we took of Copernicus here. Copernicus is a little bit in the weeds right now because of the clouds, but you see the central peak in Copernicus, and you know the terraced walls we saw in Copernicus, okay? And to see those again, we can just go look at them again, okay? Here over in our wonderful Lunar Reconnaissance orbiter, if we take a look at Copernicus from the Lunar Reconnaissance orbiter, you can see that there is a central peak here, okay? And this central peak it's got terraced walls. When Copernicus Crater was created, the impactor struck at an angle which you can sort of tell, hey, where'd it go? All right, it struck at an angle that was almost dead on because you can see that the ray structure of Copernicus goes in all directions. That indicates a pretty much flat on 90-degree splat into the surface, okay? And the rays go out almost equally in all the directions, okay?
By the way, we should say hi to Carol and Papa Tom. I'm sure he'll answer your question in just a little bit.
Oh, hey, Carol. How are you? Carol Carl is here. She's the KGRA radio host. KGRAradio.com for Behind the Obsidian Curtain, Friday nights at 7 p.m. Don't miss it. And Papa Tom is here.
Miss it.
How you doing? Okay. And Papa Tom's asking me, how come the backside of the moon's crust is thinner than the sun side? Okay, I'll answer that question for you. But it's actually the opposite of what you think, Tom. All right. Well, let me just say this. So when the impact strikes, right, the entire area in here in the middle of this lunar cataclysm where this meteor is striking, this asteroid, is hit with such seismic energy and kinetic energy. All that kinetic energy, that's the energy of motion of this giant asteroid, hits this immovable moon that's not going anywhere. And when it hits, all of that energy is turned into heat. And that is also going to send seismic shocks all through the surface. And as it does, the immediate area where this crater is made is effectively going to act like liquid. Now, it'll be dirt and sand farther out from the impact point, but it's also going to be acting like liquid for a period of time. And when it does that, you're going to see the immediate scouring out of this crater into a gigantic bowl, and then that stuff is going to pile up on the sides and then come rushing back in, just like with a water droplet. When you drop, say, a droplet into a water, you actually see a little bloop in the center, right? You see that, and that little bloop that you see in the middle is where the water comes back up. Well, when it happens in geology, in geological situations like this, we get a central peak. There's the bloop right there. And for craters that have that, like this one here, okay, and to a lesser extent, this one over here, okay, and all over the moon, like Taiko, as a matter of fact, then we get that bloop. And sometimes the impact is such that it makes this complex crater walls. These are called terraces, and that's what we call these, right? And you can see that we have many different types of terraces within Copernicus. And if you want to know, just with the Lunar Reconnaissance Orbiter system here, how far you can go down, well, let's just pick a crater. Let's pick this crater. Let's go on down. Let's go to the moon.
Pick it.
There we go. We're going to the moon. Okay. All right. And now we're going down to the moon even further. Can you believe this? Can you believe this, folks? Look at this. Individual boulders. Okay. Boulders like this are around 40 feet across right here, maybe 50. Okay. But you can see down to things that are about 12 feet, 13 feet across. Imagine navigating through this. It'd be like going through parts of Utah or Nevada where these massive boulders are. You can imagine a whole highway coming through this, right?
Easily. Like the Arizona Impact Crater, if anybody's ever been there.
I was.
It's teeny tiny compared to a lot of these moon craters.
That is correct. That crater is only
it's huge.
That crater is only about 1,000 feet across in Arizona. And let's find out how now. For anyone who's asking or thinking about it, let's find out how far across this crater is. Let's go here and right to there.
We're taking guesses.
No. It's 2.6 kilometers across.
Yeah.
Okay. So, that's actually
Walmart parking lot.
That's a pretty good sized crater, isn't it?
Yeah.
But we can come down into this crater and see all this tiny detail. Look at that rubble down there. And craters like this have other features too. If you just take the time to look around, well, you can see this is a slope here that actually had some kind of avalanching material that came down the slope here and tumbled down. And it could be because of material that actually, or a meteor that hit, some miles away.
It's kind of sad, isn't it?
Why?
Just look at all this like stuff that needs to be explored, and
I know.
we're sitting here on this planet.
Yeah, you're right.
We're getting.
It's true.
Yeah.
It's true. And honestly, I don't know what to tell anyone when they suggest that maybe, we should have gone to the moon, we should be to the moon or whatever. But yeah, we should. But we're not there yet. We can't do it yet.
It's not easy.
No, it's not easy. Not easy at all.
Don't say we can't do it yet. Don't do that.
We can't do it yet.
We're going to have conspiracy theorists clip it.
Conspiracy theorists will conspire.
We can't get there yet. We can't do it. So how do we do
conspiracy theorists, Mr. Data? I don't care.
Emissions.
Yeah. So there you go. So that little crater we just zoomed in on right here is sitting there. And except for the Lunar Reconnaissance orbiter, you'd never know this was here. You'd never see all this intricate detail and incredibleness. And then you zoom out and find out it's just part of Copernicus. It's a tiny crater near Copernicus.
He's just a little guy.
Yes, he is. He's a little baby crater. And then you got this crater right here inside Copernicus. I think that's
And a lot of people have asked why. Well, if this is a big thing, why doesn't the Earth look like this? And there's a couple answers to that.
There is.
Your biggest two answers is three answers. Number one is it does. Number two is we have a thing called weather, which really plays hell with craters over time, over thousands and millions of years. And the other thing is water. We have a lot of water.
Yeah, we
that's
do.
hiding a lot of stuff.
That's right. We do. And our water, and it's erosion is what it is, We have an atmosphere, and the atmosphere erodes and weathers away craters. We have a very dynamic planet. It's always changing. Tectonic plates are rumbling and grinding against each other for millennia, millions of years, billions of years. And this has changed the face of our planet. Our planet looked like the moon at one point. It looked like the moon. In fact, when the moon was getting bombarded by what we call the bombardment eras, okay? At that time when the moon was getting bombarded, the Earth was too. And the Earth was getting pelted with these things. But the Earth was lucky enough to have been able to form an atmosphere that could erode away and change its surface through dynamicism of the tectonic plates and that activity. And so what we see is the result of that on Earth. All right, a fertile land that just has endless opportunities for growth and life. In fact, we're finding new craters all the time. Underneath the Greenland ice, they found a crater a couple of years ago, one of the larger craters on the planet, and it was an impact crater from a long, long time ago. Do you remember that one, Keith?
Yeah. I also remember somebody coming up and saying that was it in the Gulf of Mexico, off the coast of Mexico?
Yeah, the Yucatan.
Giant one was found. Like a really big crater that they think it's a crater.
Well, yeah, that was the Chicxulub impact.
Right. Say that again.
Chicxulub.
Right, the Chiclet impact.
Yeah, the Chiclet impact. Okay. Yeah.
Yep. Exactly.
Yeah, Chicxulub was the one that was 65 million years ago. The one that killed the dinosaurs. Basically, that was that impactor.
Yep. The Chicxulub.
Yeah, nah, Chicxulub.
What is it?
CHICX.
Oh, now you're spelling.
LUB. Chicxu. That's the XU. Lub. LUB. Chicxulub.
Chicxulub. Gotcha.
Yeah.
Giggity.
Whoa, see that? Giggity, giggity, goo.
No, now I'm saying it wrong. Chicxulub. It's pronounced Chicxulub.
It's Chicxulub.
Okay.
Chicxulub. Yeah, Chicxulub. Found by two guys that were actually looking for promising oil shale for the oil companies, and they actually found the impactor location that changed the course of history on the planet. Yep.
Classic Earth.
Mm-hmm.
It's finding stuff through greed.
I know. By the way, just so everybody knows, we're looking at the moon now in visible light. We're seeing it as it looks to your eye. We do have other filters, and this tab down here brings us to this filter here is called the narrowband 1, and it just uses it looks at tiny slots throughout the overall spectrum that we look at, used for nebula mostly. Narrowband 2 is slightly wider, but does the same kind of thing. Narrowband 3, actually it's not narrowband 3, spectral 3. This one is the one that actually shows us spectral data. But we have we're installing a spectrum system, an actual spectrometer on the telescope. We'll have this on one of the telescopes for SkyTour. Probably the East Coast one here is going to have the spectrometer on it, and the West Coast will have.
So you guys can see it in virtual reality.
Well, that's the next thing, okay? Because when we actually when we create our images of the moon, we're going to be taking images of the moon here in Connecticut with the same telescope as we're doing in Arizona.
And the same telescope was in Miami.
That's right. And guess what you can do?
Wow.
We are going to create the first ever 3D images of the moon that you'll be able to look at and use the cross-sight technique, at the very least, to see the entire moon in 3D. I think that's pretty cool.
And go adventuring.
Yep.
And touch it. No.
And then you go up with Elon and,
Yep.
Roger that.
So stay tuned for the SkyTour LiveStream 3D interactive
Lunar Surface Explorer.
PK Tour stream with Mark, maybe? I don't know. We'll figure out the name later. Either way, it's going to take everybody.
It's definitely going to be a crazy time.
Yeah, and we got to have clear in every spot. But it's going to be cool. It's going to be cool.
It will. It will. I'm focusing now just to try and focus a little more here. Okay, that's out of focus. It's hard to try and focus when there's clouds, but you know what? You got to just... You literally focus on the noise.
Yeah, got some atmosphere going on up there.
Yeah.
Big.
Yeah, we do. Yeah, we do. Mm-hmm. We'll get it.
Daisy asks, will we need 3D glasses?
If I do what's called an anaglyph, which is the red and the blue, then you will. But I'm not going to do an anaglyph initially. I'm just going to do two side-by-sides. And then I'll teach you how to turn that without any glasses into a 3D image. It's called the crossed eye method. And I discovered that as a kid, and I used it for years and years. But it's a very well understood methodology, and no, your eyes will never freeze that way. That's an old myth. But it's really very helpful to be able to study these things.
Coming to an Oculus near you sometime.
Mm-hmm. Oh yeah, so we need to do a little more work here. This is not focused enough. So let's do that. Okay. So, since we have a moon again, let's play around. Oh, I just saw a cloud. Okay.
Oh.
Don't worry. I won't tell it. Let's just do...
Astronomy. You take the hand you're dealt.
That's correct. But that's why I was telling you, out in Arizona, we don't necessarily have to worry about that so much, because we end up getting very clear skies out there, even when the skies are cloudy elsewhere in Arizona. It's very nice.
Also, like anybody that buys a telescope, and people that have should already know this, that if you do go buy a nice telescope, or even just a classic consumer version of a telescope, it is almost guaranteed to be cloudy and raining for the next 2 weeks after you buy it.
That's true. So don't buy any telescopes in Arizona.
So if you need any rain anywhere, having a little bit of a drought, go ahead and buy a telescope. Should be over soon.
That's right. You buy a telescope, and next thing you know, it's gonna rain.
It happens almost to everybody I know.
What happened here?
In 2 weeks, it's just raining and cloudy and miserable.
It happened here. We had the same thing. Okay, I think we're looking at... I have high clouds. Yeah, I've got me some high clouds. I don't want some high clouds. But I see them crossing in front of the moon right now. See? I don't know if you can see those.
Yeah, just see them gonna cross.
Yep. No, it's not something wrong with your eyes. Those are clouds crossing across the moon. But, we can go back to this and check it out in pure, most pure fashion here. So, pulling out of Copernicus here. So I showed you some pretty interesting things, with this. You can do some really cool things with Lunar Reconnaissance Orbiter Quick Map. This is Plateau. Plateau is a wonderful crater. It's 60 miles across, right? And I really like Plateau because it's actually one of the most interesting locations on the moon to me. It is.
But I should mention, if anybody wants to go visit a part of the moon that they've seen on either our stream or Mark's stream or somebody else's stream, and you want to see it up close, tell us. I mean, we have a semi-cloudy night going on. We're playing around with the LRO. Let's check it out.
We could go anywhere.
Hell yeah. Let's do it.
Look at this little tiny crater. Look at this little thing right here. A little crater. No one knows what it is. It's sitting way out there, outside of Plato.
Big ray pattern. That's crazy.
Yeah.
So you tell that had some force behind it when it came in.
That's right. Well, I think we should probably do the obvious, don't you think? We should do the obvious.
Well, it depends on what the obvious is. I mean, we and you have two totally different of what obvious is.
Oh, well, what I mean by that is anthropogenic features.
Yeah, that's not what I was thinking. But go ahead.
What?
Only you would think anthropogenic features was an obvious place to go.
Oh, yeah, that's true. Okay, what I'm getting at is...
I would have said, like, hey, a crater or a complex crater, maybe if I was into the moon, or possibly, some mountain somewhere. But you just came right out with it, didn't you?
No, I mean, like, here, this is Apollo 15's landing site. Okay? So
no, Rockwell, please judge me on that last vid. Please.
So here's the Apollo 15 landing site. And let's just take this off for now. And you can see the lunar module right here. You can't miss it. It's right there.
Yeah.
Okay? And here are the tracks of the rover, right here. Here is the ALSEP experiment, which is one of the experimental packages they laid out. You can see the tracks. You can see the shadow of the lunar module's base. You notice it's flat on top. It's flat because there's the lunar module ascent stage, the thing that had the men in it, took off and left behind.
And for anybody, moon conspiracy people, go ahead and pull up the Apollo footage and look and line it up and see the craters they drive past and around and
see it all for yourselves. And then go back into your basements and cry. We were there. Like it or not.
Yep. Whether you like it or not.
Yeah. But there's some cool things about these places that we went, which is really, I gotta show you. When the Apollos left the moon, one of the things they did was they jettisoned, or when they went to the moon, they jettisoned a stage that was used to hold the lunar module, and they let it crash. I think that was fifth stage, was it? SR?
Yeah.
I think that's what it was.
Mm.
Yeah, at fourth stage, sorry. Okay, so for instance, Apollo 16's right here. All right, and so now you're going to see a human-made crater. Okay, and to see that, let me just kill that.
Imagine that poor intern that had to go find that.
Oh, you want to hear about this? Okay. I'll tell you. There it is. There's debris. That's the debris of the stage inside this human-made crater. All right. Isn't that incredible? Now, I can't do it tonight because I can't find it, okay, too easily. But you can actually go, and I'll do it for one night for you. You can actually see that when the astronauts left the moon and they came from the ascent stage of the lunar module, they went into the command module again. And to leave and go home, they jettisoned that ascent stage, which was in orbit around the moon with them, with the command module and the service module, right? And then that thing slowly spiraled around the moon until it crashed back into the moon. And it left its own debris trail. But it was a long, shallow, like skipping a stone, it was a long, shallow strike on the moon. And remember, it was full of air. So the first impact would cause it to just explode.
Boom.
Yeah, and it was the inward pressure escaping, so it was like, and it made this debris field. And I actually found one of those debris fields here on the moon for one of the Apollos. But there is an intrepid person with no life out there who did a search to find these and found all the other locations, and it is amazing. Really, really impressive. You know, so
I admire their persistence.
I do too. I thought it was a really, really good, a really good thing to do, because I always wondered where those things went. Okay, now where's Copernicus here? Okay, if we look at Copernicus Crater, okay, right up there. Okay, down here. All right. Is it down here? Yeah, that's Apollo. That's the Apollo 15's. This is Apollo 15's stage that held the lunar module, and now you can see its crash right there. So check it out. There you go. Now, for those of you out there looking at this, and it's a test question. Which direction was this thing? This is the debris is in here. You can see the debris in there. Which direction was it moving when it struck the moon?
Give them time to answer.
I'm not saying a word. Which direction was it moving?
Oh man, I've been looking at the screen now. Everything looks like a bubble instead of a crater. Hold on, I gotta readjust here. Let's see. Left eye, right eye, left eye, right eye. Cross-eyed. There we go. Now they're back into being craters again.
Mm-hmm. Okay. Which direction was it moving when it struck the moon?
First correct answer gets absolutely nothing.
Well, anyway.
Let him. Hey,
I'm not
Remember,
going.
that's
I
the
know.
second-
I know, but while they're thinking about it, okay, just remember this. We got here's the crater impact. You can see some ray structure sticking out. You figure out which way it was going. Meanwhile, let's go check out the moon. We still have clouds crossing our real moon that we have been looking at.
The moon.
And I'll just increase the brightness a little bit.
By the way, since I'm live here with Mark, I will mention P&K returns. Possibly tomorrow night.
I love it.
Weather permitting, and I might have this this dude with me.
Hey, I would be happy to do it.
We do our spurts, don't we, Mark? Seems like we're on each other's stream for a good 3 weeks straight, and then all of a sudden it just stops, and then 6 months later we're back.
Well, that's due to the weather, unfortunately, you know?
Yeah. Well, weather and life. It gets busy.
It does. It does indeed.
To my defense, I did warn people at the beginning of the year that P&K streams were going to be sparse this year. So
You did, actually.
I think a lot of people actually forgot that because it was way back in January, that like 14 years ago.
Yeah.
Which was like 14 years ago. But yes, I did warn people.
Okay, I got some answers here, and people are suggesting now. So, okay, so we come back here, and you see this is the Apollo 15 Saturn 4B booster crash site. And I ask which direction this was moving when it hit the moon. And I see answers that are east from Carol Carl. Justin Time says right to left. And Isabella Melamed says left to right. I think that's enough answers, right?
Yeah, go ahead.
Okay.
They answered.
There's one answer that's correct of those three. Assuming east meant going this way, to the right.
When people say that, I think, you do the classic compass.
Yeah. Basically, the impactor struck at a glancing blow that pushed a lot of the debris out this way. Okay. And that glancing blow had to come from the right, moving to the left.
You have it.
As you can see, just in time, had the correct answer. Carol Carl, thank you for playing. Isabella Millimet, thank you for playing. You are superstars in your own right. And
I should mention that Siobhan Hurd is a very, very good friend of mine. Thank her for joining.
Siobhan, hey there.
Mark's channel as well.
No, please feel free to subscribe, Siobhan.
Yes, Siobhan, feel free to subscribe.
Yeah, please do. Yeah. So there you go. So that's kind of what happens. Now you might see that there's stuff going this way and stuff going this way, but you say, well, wait, what about in the middle? How come it's not just an even split? Could be a lot of reasons. Number one, it could be that there's topography of the moon here that prevented the stuff in the center from going out, or this thing could have struck it just the right way so that the primary amount went this way and that way. But again, it was going this way first and struck the moon at an angle. And then it struck and dug in such a way that some of it went backwards. And that always happens a little bit. But the predominant bulk of it went this way, and that's the stuff we look at. I will find where the lunar module itself collided. There's a sequence where you can see the lunar module had collided with a mountaintop and exploded, and you start to see pieces littering miles afterwards on the moon. It was really incredible.
Didn't we look that up before?
Yeah.
Yeah, I thought we did. Yeah, it was, and we were kind of taken aback when we saw it. We're like, "What? Really? Oh my lord!"
Oh yeah. Really something else. Yeah. Something else. Yep.
Something different.
Yes, Carol Carl, you can come back next week. Thanks, Siobhan.
Once again, Carol, you can check her out.
That's right. Carol Carl, Behind the Obsidian Curtain, Friday nights at 7 p.m. on KGRAradio.com.
Along with our friend here, Mark D'Antonio, live on the KGRA once again at, what are you at now? 8 p.m.?
Sunday nights, 8 p.m. to 10 p.m.
Yeah. Good for you.
Yeah, we have a good time. Yeah, it's a good thing, yeah.
I mean, I haven't listened lately. I should. But wasn't there a rerun recently?
Well, yeah, because for the last 2 weeks I was filming that
That's what
show. We were running around New York State filming a show about paranormal and UFOs. And I was one of the cast members of this trio of investigators that was out there. Major network, so it should. I don't know when it's going to be out, but if it goes well, then we will
drop
be doing more.
You want to leave us all hanging or what?
Yeah, I can't name drop because I'm not allowed to name drop. They told me I couldn't.
Yeah.
But if you just say it and I don't say it, well,
In there, and you didn't name dropped yourself.
well, that's because I was telling people where I was for the last 2 weeks.
Oh, okay. Alibi. I got you.
Yeah.
Get you loud and clear, buddy.
Oh, you're funny. Here's another one of those craters that has a central peak, a bloop in the middle, like that. In the middle, like a water drop. Okay. And this is Taiko. And Taiko Crater is the one that has these phenomenal ray structure here. Okay. Mostly a direct impact. Some of the rays go out this way, which you can't really see. All right. But look at that central peak. Oh, no, wait. Don't take my word for it. Let's dive into the central peak of Taiko Crater. Okay. Now, I think you can see how when we look at the central peak of Taiko's crater, we are seeing a tremendously weird looking terrain. It's really strange looking, but look at, now we're getting down to individual rocks and boulders. We're seeing areas here where there were fractures in the ground and landslides, piles down here that land slid down into there. Just the crazy stuff. And you can see stress fractures and stress cracks here all the way down on the sides of this central mountain here. Massive blocks the size of houses or beyond. Let's actually see if the resolution is good enough to determine if we can see how big this is. So let's see if we can get this block. It might not work because it might be too low. It might not give us what we want, but let's find out.
It's pretty big.
Oh, it says 0.029 kilometers.
Wow.
So that's if you do that math, figure it out. 0.029 kilometers is going to be a lot bigger than a house.
But it's not the size that matters, guys. Just how it got there.
Funny guy, but
hey.
You're right. You're right.
Zing, that's what I'm here for.
Yep. Zing.
Just think about it. What did you say it was? 0.29?
0.029. Yep.
Zero. Yeah, so yeah.
Yeah. That's 95 feet.
Yeah, that's big.
Yeah, that's pretty big. So that's about that's a 100-foot rock right there.
Yeah.
So by comparison, you can say something half the size would be about 50 feet. So this is about 50 feet across. Okay, this one down here. And this is all inside Taiko Crater as we zoom out.
Dude, that's still insane how much, like, when you're up close like that, you're looking at rocks and how far you have to zoom out before it's this.
Yeah.
LRO was one of the greatest accomplishments.
It still is. It's still running.
One of the greatest, and I think James Webb's going to be a little more, but still the importance of the LRO should not be negated by.
No, we talk about that all the time.
Yeah.
Lunar Reconnaissance orbit is great. Now, see, what were you gonna say? I'm sorry, I don't mean to cut you off.
Oh, I was gonna say we're both talking to you. We were both pretty excited about James Webb. And anybody that doesn't know me, I've talked about this on the P&K channel as well, that I truly believe the James Webb Telescope is going to open the doors the same way the Apollo program did for NASA for space exploration. It's going to show us so many new things.
Oh, it will.
It's literally going to be, as long as it goes right, as long as they get it out there and they park it and everything, does what it's supposed to, and works, and it gets there, it is a game changer.
It is, and will be.
Game changer.
Oh, we got
like
some
Mark here is an expert in exoplanet study. That's what he does. That's who he is. You see him on the Travel Channel and all that stuff. Forget about that crap. This guy, I mean, for now.
I do.
Exoplanets. This is what he does. And with this James Webb, you're actually going to see the makeup of other planets around other stars
And their atmospheres.
We'll
We'll be able to infer whether there's planets with oxygen in their atmospheres finally.
Complete game changer.
Yeah. By the way, Shoban liked the water drop sound. So
Yeah,
I'm gonna teach you
that's
how
pretty
to
good.
do it. You go like this. You go like this.
Yep, you do it the same way I do it.
You flick your cheek and go. "Mm." There you go. That's
Okay, now that we've been canceled.
right. Oh, nonsense.
I mean, we're pretty good at sound effects. Everybody knows the other sound effects we're good at, but we won't do that here to Skype.
Yeah, no, this is a family show.
Well, there's nothing says family like a good meal and a...
Hey, so yeah. So anyway, the moon. So we're looking back in the central peak. I just want to say, you notice how there are these large, massive fissures. These are giant fissures. Okay, how giant? I'm glad you asked. I can show you. Okay, if we just do a little bit of a little line right here. Okay, this fissure goes to about here. It's roughly straight. But how long is that? It's 0.087 kilometers. So we're looking at something.
Fissure or is it fissure?
Fissure, if you're from Great Britain.
Fissure.
You know.
Oh, yeah, it's
Fissure, it's a fissure, but fissure in Britain. No, but see, and this here is well over 200 feet long, okay, this thing right here. So we're talking about something that's really massive. And as far as width goes, knowing how wide we can see, knowing the width we can typically see, I would say that we're looking at something that is probably about 25 to 30 feet across, maybe 20 to 25 feet. You know, really immense object, a giant mini canyon, so to speak. And that's just one crack at the top of the peak. These cracks formed because of all the other impacts on the moon. As the impacts occurred, vibrations and seismic shocks went all throughout the moon, and they went to places like this at a peak of a mountain where it was so easy for the material to be sloughing off and falling away. So we end up seeing these types of appearances, these types of anomalies. It's really impressive, you know.
I was going to ask you something. I forget what it was. And it was important.
Oh, well, go ahead and ask anyway.
When do you think how long ago do you think the last major impact was?
Well, major impact?
Yeah, I'm not talking about like the little guys, you know. I'm talking about like, let's think about on the terms of major craters like Aristarchus, Taiko. When do you think the last one was? Because there is a way we can tell that. I mean, you have talked about this before with how the sun rays bake the the surface. So, and this might have come up before with you and like other people, but what do you think is the last major impact that happened? How long ago do you think it was?
I don't know which one it was in particular, but I think we're talking millions of years.
Yeah.
Yeah. And we have to go back billions of years for the biggest.
So you're thinking like at the end of the heavy bombardment area?
Heavy bombardment era, yeah. I mean that was.
Yeah, era. I'm sorry.
Yeah, not area. You know, whatever. You know, I know what you meant. Okay, I was doing the subtle correction so you wouldn't be all embarrassed. You know.
Oh, you know me, because that's Mr. Embarrassed.
Yeah,
right?
Because you just can't handle it, right?
Yeah. Make me do it, Mark.
No.
All right. Okay.
Okay. So anyway, I'm just taking off my sweatshirt here because it's a little warm in my office here, but it'll be going back on when I have to go outside to close everything up. Later. That'll be later on. So, now you were talking about the heavy bombardment era?
Correct. Or area. Whichever.
Yeah. Well, at that time, there were so many different impactors hitting both the Earth and the Moon that it was probably hard to tell what was the biggest, because on the Earth they were just getting covered over by another one after that. Massive impacts, right? Same thing on the Moon. That happened, and we had all kinds of impactors on the Moon. But if we zoom way out, okay, we can come out and see that some of the impactors, okay, if you want to understand the chronology of the impacts, here's one way to do it. If you look at the Moon, let's look at this white area right here, which is crossing that crater, okay, this white area was laid down after that crater had been made and filled in. So that gives us a lot of information right away.
Why don't we tell people how we know that?
I'm about to.
Well, you better.
I'm going to. Now, if we look, this is a major impact site. This is one too. There was a large circular object that hit here, or whatever it was that hit, it left a circular crater. And because it punched through the skin of the Moon here, the inner lavas from the still hot Moon at that time during the bombardment era allowed this material, this lava, to come flowing out onto the Moon. Okay, and then it cooled. And then other things hit, and that's what you see here. Other impactors struck after all that. Same thing over here when we looked at this other moon, this other ray structure. Okay, we look at this ray structure that's coming out from Taiko, and we see that there's this crater. This crater was made, it was a round crater, probably looked very similar to like this crater over here. Might have been identical, maybe a little bit less. But then it was a crater that ended up getting filled in by other material. Okay? And that other material was created by another impact. Right? That then flooded this crater and filled it in. Right? Okay.
That's flooded.
Are you back?
Okay. I don't know if you're. I've been here.
Okay.
Everything just kind of went. People in the chat, did everything just kind of go blank for you for a second? Because it did on the Skype end. I was watching the YouTube the whole time. The YouTube is good. It was solid.
Okay.
But everything on Skype just stopped. And now you're back.
Yeah, I guess so. Well, anyway, this crater here, you can tell chronology because of the nature of what overlays what, okay? If you have a crater that has a ray sticking over it, then whatever created that ray happened after that crater, because it showed stuff come down on top of it. Had this crater come in, you'd see a big hole here, and this ray structure in the middle would not be there. It would have been dissected. What's that?
Our moon, in layman's terms, our moon is a big baked potato. And our sun is constantly throwing rays at it. Microwaves, yes. Gamma rays, all this good stuff.
Well, the solar radiation is pretty intense.
Correct.
Yep, that's right.
You're right.
And another thing, and all these little things on the moon are so cool. Look at these little ridges right here. Can you see these ridges? Okay, we got these ridges right here. Okay, look at that right there. This ridge right here, these ridges. Okay, they come around. Look at these little guys. You know, you look at these, you want to get close to and personal with these and see what they are. And when you zoom in, you notice that they look like they're raised areas. They're actually not. They're actually sunken areas. And the slopes have rocks on them like this, and it tumbles down into this rounded bottom. Okay, this is a rill. Okay, and it could also be a collapsed network of lava tubes underneath the surface here.
Measure it.
And we can measure it too. You want to measure it?
Let's see how big.
Okay, let's do that.
Connecting point. Let's do the connecting point. Yeah.
What do you want to do? You want to do like from here to here, across?
Yep.
Yeah?
Yep, let's see what we got.
Okay. So, the size of this rill going across the bottom is almost a kilometer. It's 0.86 kilometers across. And if you think it looks like a raised area, like it almost looks like a surface vein, well, the data belies that thought, because you can see that it actually goes underneath. It goes down below the surface. And if you look on the main screen over here, you'll see that the crosshair travels along this line like this. Watch. Here it comes. And this is the lowest spot right there, as expected. And then up. See?
By the way, Papa Tom asked a question a while back, and I didn't want to miss it.
Yeah.
It was Papa Tom. Here it is. Mark, what would be your guess as to where NASA will put the first moon base?
You know, that's a good question, Papa Tom. And the answer now is it doesn't matter. Why would I say that? Because
You're crazy.
Yes, because I'm crazy. No, up until a couple years ago, we looked for water only in the craters that were in permanent shadow on the moon, because we thought that's what we had to do. All right. So, for instance, if we look at the south pole of the moon right here, okay, there are craters here that never see sunlight. Okay. And one of those craters that never sees sunlight is one called Kbs Crater. Okay.
Good old Kbs.
Yeah, Kbs. That's right.
Studied, analyzed.
That's
I think
right.
what's even crashed into.
Mm-hmm. And this
You
is
know,
Kbs right here.
All that studying just down the drain when we found more water.
Well, not down the drain, okay, but it was different. This is Kbs. This is the area that we thought was where we had to go.
And it's true with the moon. All data is good data when it comes to planets or moons or stuff like that.
That's right.
Nothing bad data.
Kbs right here was thought to be a interesting site. We could put a base down inside here, Tom, because that's what they thought would be needed, because that's where there might be water. And when they crashed the LCROSS, LCROSS, it was basically a stage of a spent rocket that they crashed into Kbs Crater. They then did a spectral analysis of the material thrown up by that impact, okay, and they discovered that there was water, just like they thought. And so there's ice here. Permanently shadowed areas have water in the form of ice. So they thought, humans need water, we have to go to Kbs, right? And they did all the analysis of Kbs. They did things like this, where they figured out what the cross section of Kbs Crater was. You can see it here. It's high there. You'll notice the crosshair on the screen. And then Kbs was actually minus 4,130 meters below the mean lunar radius, right? And then it climbs again to come out here in this little area over here. Well, the truth is, that's what we thought we were going to be constrained to do, was to have a base near the lunar south pole, where there might be water in a shadowed region. Well,
I personally think this is going to, with the discovery of water, and you might agree or might not, and we can debate that, but I think this is going to lend more credence to putting a base around either a lava tube or using a spent rocket body as the first kind of base. Not a major base, but like the first one that can actually be used.
Well, keep in mind, we'd have to somehow get it to get it to the moon. I think the best...
Everything else, just throw everything at it.
No, because they'll never get destroyed. I think the best way to do this will be to actually bring down one of those inflatatats, as I call them. Okay, Bigelow Aerospace makes these inflatable modules. One was on the space station for the longest time. And
Bigelow.
They'll probably bring that down uninflated and inflate it on the moon. And then they'll have an inflatable module. Now, the soil on the moon is extremely abrasive. It's actually like glass. When the astronauts walked on the moon, I think it was Harrison Schmitt, he couldn't go on his last moonwalk because his spacesuit ankles had been cut through to the insulation because he was just sifting through the lunar soil. It's like glass. That's what you get on the moon when you have many, many billions of impacts, and there was probably billions.
And here's your fact for the day. When they got back, duct tape was invented.
See, that's a cool fact.
Yeah.
Okay.
Even though it's absolutely not true.
Oh, well then that's a cool fact, but it is true because duct tape wasn't invented until after the Apollo era, but it had nothing to do with the Apollo era.
Right.
That's right. So,
Good tape.
What?
It's good tape, though.
Yes, it is. So is the Gorilla Tape.
Yeah, Gorilla Tape's really good.
So you see, what happened was they discovered something else, which I think is really cool. And that is, now if you go down there, Taiko, there's a study that was just concluded, and it was discovered that Taiko Crater, of course, everybody knows Taiko, but another crater that everybody knows is one called Clavius. Okay, and I'm going to just go to show you. I'll show you Clavius the proper way. Okay, I'll tell you why too. Okay, when we look at Clavius Crater, all right, which is right here. Okay, and for proof of that, we can just go get our nomenclature again, and you'll see Clavius right there. Okay, this is Clavius Crater. Now, they did a study of Clavius Crater, and they discovered that in the soils of Clavius Crater, a crater that's bathed by by sunlight all the time, okay, for 28, or was it 17, 14 days at a clip, right? It's actually got light from the sun in it. They still found that there was copious amounts of water in the lunar soil. Soil is also called regolith, regolith, and this soil actually had copious amounts of water in it, in Clavius. And I thought that was really kind of poetic because in 2001: A Space Odyssey, the first moon base was in Clavius Crater, which is kind of cool. And in that movie, they also went to Taiko to analyze TMA, TMA1, the anomaly TMA1, which is basically the black monolith found in that area on the moon. Similar to the stainless steel monolith found in Utah.
Yeah.
Yeah. So that's pretty cool.
Yeah.
Hey, Terry, Terry Groff mentions he's got a tornado watch. Is that a warning or a watch?
Where is Terry Groff located?
He's in Texas.
So friends in Texas, be careful. Don't get swept up in the NATO.
Yeah. But I remember that we were down in Danbury, Connecticut filming. And for those of you that may know Ben Hansen was one of the other cast members with me. He's a great guy, a good friend. And Ben and I talk on the phone, and I hear a warning come over the phone. There's a tornado on the ground near Danbury, Connecticut. This was just a few days ago. And the next thing I know, Ben's knocking at the door. He goes, "Come on, let's go look at it. Let's go find it." So we go out in their car that they gave us, and we went hunting for this tornado. And it was actually, when they issue a warning, it means it's on the ground. It's been spotted, and that's what Terry Groff's in the middle of. Terry, take care, man. So we go out to the car, and the wind is really, really picking up. I open the door of the car to get in, and all of a sudden, a gust of wind that is really more water than wind. It was like an ocean wave. Just hits me in the side. And
that happened to me here in Pennsylvania. It was probably 2 or 3 years ago. I walked outside and I was like, "What?" They were calling for a storm, and I had to be like 25 feet from my house, and all of a sudden this gust of wind just came up and slapped the crap out of me. I'm like, I literally know what it's like to be slapped by a gust of wind. Like, it hurt.
This was a slap of wind, but it was mostly wave of water.
Yeah, well, this was a slap of wind.
Yeah, this was mostly water, and I literally go to get into the seat. All right, these are leather seats of this beautiful car. All right, it's a SUV, a Tahoe, black Tahoe SUV, and I go to step to get in, and as I'm getting in, I get splattered with this is literally effectively a wave, and so much water comes in, it fills the seat, and I sit down in water on this seat, and I was like, "Oh!" And of course, Ben starts laughing, and he's going, "Come on, we gotta go." So we went and we tried to catch it, but it was actually too fast for us, and it made its way out of Danbury before we could get to it.
By the way, good night, Papa Tom, and hello, Charles. I didn't see you on there.
Charles Smar is here, yeah. And hey there, Tommy, how are you?
And Tommy.
Yep. Yeah, so this tornado came and went, and we didn't really get to see it too well. But I'll tell you, me soaking wet. Okay, we decided to go to get ice cream.
As you do.
So we walked in at the ice cream place, and they go to Ben. "Yes, what would you have?" And she looks at me and goes, "What will you have?" I look like a drowned rat. I was totally soaked head to toe. And I said, "I'll have a little vanilla with peanut butter mixed in." And she goes, Oh, okay. She starts mixing it up, and I'm standing there in this. It was really hilarious.
Some wet hobo out here trying to get ice cream.
That's right. And she was looking at Ben to see is he with you? And I actually played along. I said, no, I have never seen this guy in my life. And of course he laughed, and that ruined the fun there because she knew I was not telling the truth. So, but anyway, that was that. So Terry, make sure you be careful out there in Dallas where you've got your tornado warning, which means you got one on the ground.
By the way, if anybody is new here and wants some good stories, just let me know because I will lead Mark in that direction. Telling some funny stories. Because there are some doozies.
No,
especially when he was a little terror.
And unfortunately, they're all true.
And setting fire to his poor dad's grass.
In his favorite tree. And that it kind of went up the tree, too.
Yeah.
Yeah, I was playing fireman. I had this little Tonka truck that could squirt water in a little tiny stream of water.
Yeah, okay. You were like a terrorist.
No. I was actually experimenting with technology.
Yeah, sure.
Yeah. I just can't forget when he came out and saw the backyard. He comes out with the pool strainer in his hand. He's going to relax after a long day of work. He's going to go in the pool and get all cooled off, and he's going to strain the bugs out of the pool. That was sort of a ritual for him. He comes out with the strainer from the back door. He looks at the backyard, and it's all black. And he just drops the strainer.
Yeah.
And he goes, Mark! Wait, what do you mean? It could have been one of my sisters. No, it certainly couldn't have been.
Yeah. Because weren't you like testing like a little, like a Tonka toy fire truck or something?
I thought it'd be pretty cool to have a real fire to put out with my Tonka truck. And at first it worked great. I was going making little siren sound with my little tiny snorkel truck squirting a little tiny stream of water on this little tiny fire, which rapidly grew out of control because of the wind. And when it jumped 15 feet away, well, that little stream couldn't even go more than 6 feet. So I was like, oh no. So I quickly disconnected it from the Tonka truck and the hose that was feeding it. And I ran over to where it was with the hose, and I started squirting, putting my thumb over the nozzle to make it go further. And now there was no more making siren sounds. There was trying to save my butt from my dad when he got home. Yeah. And I lost about, let's say, 25, 30 feet by about 35 feet of lawn.
Was your dad one of those people that were like proud of his grass? Like
no, not
like one of those,
No,
so.
Not that. I'm still alive, so obviously that's not true. By
the way, Wahoki81 in chat.
Wahoki, how you doing?
That is also a very good thing. We have always marveled at Clavius and how it has a constant declination of crater sizes going down, except for the last two. But
yeah,
it's in a half moon pattern. It's what makes it absolutely unique and probably one of my favorite craters.
Yep. Yeah, I mean this crater here you can see is nearly the same size as that one, but then this one is a little different size, so it doesn't really fit the pattern.
Yeah, I never count that one that's in the crater wall.
I know. Everybody counts the ones that are out in the flat. I get that.
I count the 5, but the last two are pretty much twins. 1,
2, 3, 4, 5. And I don't know why they ignore this one, because it's here going, hey, what about me? It's all,
I think it's because of how big the shadow and the light walls are on the crater.
Yeah.
It has a constant look to it.
Yep.
Yeah.
Well, and if we wanted to discover any of that, well, we could certainly do that, because we could say, well, are these craters really different sizes? And we'll go across these craters right here.
Okay, since Mark is fact-checking me live,
see that?
I don't actually think they're really the same size, but they are similar in size.
They are. No, I'm just saying. See, like right here, you can get the distance.
Hey, Keith, they're not the same size actually.
No.
It is interesting. Their depths are different, though.
Yes, that shows you that the slope that we measured on. Okay, the slope that we measured on is a rising slope going up here.
You know what's crazy about those two as well actually, what's the measurement between the two?
What do you mean the measurement between the two?
Measure the land between the two craters.
Okay. Let me get rid of this.
I see it kind of in your little graph over there, but
you want to see it directly.
Yeah.
All right. So let's go from here. You're saying?
Oh yeah, and let me look at you.
From here.
There you go, just like that.
To there.
Oh yeah.
Yeah.
Wow.
So the distance there is 20 kilometers.
Yeah, that is a different story than what that straight line across both of them told.
Mm-hmm.
But once again, bigger area.
But if you notice, this crater is actually just a hair bigger.
Mm-hmm.
You know?
Go ahead. I knew you were waiting.
I was. I wasn't going to say anything. I was just...
When you straight line across, so, I mean, well, you said it was, what was it, based on a 50-foot or 50-yard? The measuring tool there?
No.
Something other, like, because remember we were saying how long it could go?
Yes.
Like what area you can measure? I wonder what's the shortest area you can measure.
Well, okay, this crater is 12.8 kilometers across.
Right.
Okay.
Can you zoom in anymore?
Huh?
Can you zoom in more than that?
And that's it. Well, actually, we can go to here.
Let's see what one of those little ones around that crater is.
Well, let's do the other. Let's do the other measurements first, because see, when you zoom in, you get better data, and what's happening is you will find that sometimes the data goes seemingly worse, but what's happening is you're getting it from different sun angles. It's this view that you saw here, but from a different sun angle. Okay, so that's why it looks the way it does. All right, so this crater then is 12.8, right? And I'll measure the same one here. I'm going to come zooming into this crater, and I'm going to measure this as well. Okay, well, let's do that. So we'll measure this crater. We'll go from here to here.
Once again, you're measuring in miles or kilometers?
Kilometers. Okay. This shows that this crater is slightly smaller than this crater. So it does work. This is 12.8. This is 11.8. It's almost a kilometer smaller in diameter than this guy. So they're not the same size. They actually do continue to taper down in size. Yep. Deepening the mystery of Clavius Crater. Crater.
That first crater in Clavius. Let's zoom in on that guy and see how there's nice little rock formations there in the center of that.
You're talking about this guy right here.
And it doesn't look like a classic complex crater. And for anybody that doesn't know, complex craters are considered the ones with the peaks in the middle. Yep. Then you have, You're
talking about this guy.
Yep.
Well, why don't we do it in the 3D view?
Let's do it.
Because in the 3D view, it'll be a lot better.
It's always better in 3D.
Yes, it is. Well, here's the 3D view of Clavius Crater. Okay, there we are. So now, let's go and zoom in to Clavius this way.
This view of what he's doing now is usually what you see on our site P&K, or most people that zoom the moon. That's the kind of view you see. Look at that.
See that? It's almost like a little dome in there.
You would have never guessed all those hills in the crater walls.
Yeah, and let's actually measure this crater, shall we?
Let's do it.
Let's do the longest dimension. All right, now, if we go through the center, you'll notice that central peak is off-center.
Yep.
Okay, that was 49.4 kilometers, actually. So it goes 49.4 kilometers across.
Look at the wall difference. So no wonder it looks the way it does.
Yeah.
The wall height difference is massive.
That's right. It's higher at this end and lower at this end. It's climbing. It's a climbing crater. This crater is climbing the crater wall.
Do you think more of an angled impact, or do you think more of a natural lunar surface, is basically what's causing that?
I think maybe that this placed central peak that's slightly off center, probably due to the fact that it's at an angle. See, it's at an angle here.
Yep.
So when it's acting like a liquid, the liquid is going to slough toward the lowest area that it can go, right? And look at, here's the beginning of that central peak right here. You'll notice the yellow ball on the blue line in the middle, and then you see this here. And this is the direction of the downslope for what a liquefied crater material that's momentarily moving like a liquid would do.
Say it.
Liquefaction?
Yeah, my favorite word.
You mean liquefaction, you mean?
Liquefaction.
Yeah. This is a liquefacted area, and you see it comes down slope. And because this all happens within a few seconds, actually, you'll notice that when it finally came to rest and the liquefaction subsided, it was gone. The vibrations left this area, which left now particles free to just settle up and solidify where they were. Yep. Then you can see that this was off center, but it's a higher slope over here than down here. I actually want to do a different one.
Yeah, and eventually do one right across the center of that peak.
I'm gonna do one like right here, from here to here.
There you go.
Okay, this is the one that I want to see.
Yeah.
Okay, this is exactly what we would expect.
Yep.
Okay, here is the peak of the wall. When this crater struck, which came after the main impact of Clavius, it burrowed into the wall here, but it also caused the material to bunch up over here at this end, and it did it precisely because of the fact that this material is on that down slope. So acting in a liquefied manner for a brief period of time is what probably brought this material off center. You know?
Mm-hmm.
And you can actually simulate this with a shaking table. But keep in mind that a shaking table is like a vat that has sand in it that you start vibrating. And then the entire sand will go flat immediately if you had something in it. But when this impact occurred, this slope stayed intact up here. This slope was not affected, as you can see. It's much higher over here. This is the part of the original crater wall of Clavius. So other material was gouged out and other material sloughed off into this direction. It might even have like sloughed against this and then backed off a little bit, which is why we're looking at this like that. You can actually see how from a certain point of view it's centered, but it's centered within a region here.
Right.
And the rest of this was part of the original crater wall.
It just slid down.
In a sense, yeah. In a sense. I mean, I think that's a strong possibility. It could have happened that way. So
just looking at it, it kind of has that look of...
It does.
Part of the wall just kind of slid down.
Yeah, it certainly does. It does indeed.
Right.
But see, for those of you that want to explore the moon, I would recommend this Lunar Reconnaissance Orbiter Quick Map system. It's really quite beautiful. And let's see what we got here for... we don't have moon. We don't have moon.
Cloud it up a little bit, huh?
Yeah, it did. Kind of a lot of it.
Well, it happened.
Yeah, it does. But, hopefully you guys are enjoying what we're doing anyway. I suspect that.
Now that you have this like measuring tool and stuff, I almost want to an area that I haven't done myself, and I was really thinking about it.
Yeah.
So, the Cobra Head.
I
area
do. That's up by Aristarchus.
Yeah. I think that'd be really interesting. And if you don't have to do it now, but whenever
it's right there.
LRO, it'd be nice to do that in the.
There's the Cobra Head. Oh wait, you don't see it, do you?
I don't see anything.
What the heck? Where'd it go?
See you in the Matrix, glitching.
There we go.
And there we go.
Das ist der Cobra Headsens.
Because look at that little ridge on top of a ridge.
Right there, you mean?
Yeah.
Yeah. Well, let's take a look at what that really looks like, shall we? As the data comes in.
And sorry, guys, I'm nerdy about lunar stuff, so this is why I'm having to do this.
And this is why you are part of P&K Space Imaging.
You got that right.
Let's draw a cross here, Keith. Let's go from outside to here.
Fair enough.
Let's see what we get. Very interesting. You can see right there, that's the bottom of that trench right there.
Yeah.
Then it comes up the slope, down, and then down again.
Is it possible to measure just that trench? Do you think there's enough to do just that trench itself?
I think so. I think there is. Okay, so this is just the trench right here.
And yes, Charles, we are on that. We have talked about it. I know P&K. I'm not sure Mark here, but I'm pretty sure he'll be doing something of the sort.
The monolith? What's he asking?
No, Charles asked, are either of you two hoping to get a picture of the Jupiter-Saturn conjunction in December?
Nope, of course. We'd love to get shots of that. Okay, so this is about 1 kilometer across at the Cobra Head in that deep area here. That part of the trench anyway.
Like your screen's clear, but because it's on Skype, it's not. I'm looking at the data on the left side.
Okay.
So what you say depth-wise is compared to...
Can you hold on for 1 second?
Yeah.
All right, hold on. I got to take a call here.
Sure. So while Mark's peeing...
Hey, Ben, what's up?
You can mute your microphone when you're on.
No, not at all. I'm just live streaming Moon. I've got
Just go ahead and
watching,
talk over live air.
No worries.
No problem.
Yeah, go for it.
I'll just sit here and talk, and you probably don't hear me because you don't have your earphones on. So I'll just I'll sit here and giggity. Anyway, hello, and Weird Guy. What's up, Weird Guy? Haven't seen him for a while. Charles Marr. Once again, we return on P&K Space Imaging tomorrow night, weather permitting. We are going to dive into some craters. We figured we'd give everybody something to do. We wanted to do it because we figured not a lot of people are going to be out getting drunk in bars on the Thanksgiving Eve like they normally are. A lot of people are going to be stuck at home, so we figured we would try to do a stream for you guys.
Where's it located?
Looking at all kinds of stuff. So tomorrow night, most likely at dusk, we'll try to start early. We'll try to go late and do the best we can. And most likely, if we do stream, Mark will be over there. And dare I say, Bill, if I can get him, we might just try to have the whole Astro Imaging Live crew on.
You won't be able to see that with your eye.
Tomorrow night.
Can I put you on speakerphone so that I?
Yeah,
okay,
Mark
let me put you on speakerphone so that everybody can hear. Is that okay?
Everybody wants to hear. Sure.
All right, hold on 1 second, Ben.
Yep. I have no idea who he's talking to, by the way, guys.
That's the whole point. I'm going to show you.
We'll find out.
You there, Ben?
Yep.
Okay. Yeah, this everybody who's on the stream with us. This is Ben Hansen. You've known him from Sci-Fi's Fact or Faked show. Ben also worked with me for the last 2 weeks. We worked together. And he had an astronomy question. His parents saw this bright blue object out in the sky. He said it was in the southwest, you said?
Yeah, southwest.
Okay.
Like, I'd say southwest.
Okay. And we know that Jupiter and Saturn are there. You said you found that on your astronomy program as well.
Yeah, my smartphone, just in that general direction, says that Jupiter should be just above the horizon, and then Saturn is slightly above and to the left.
Yeah, and as you rightly pointed out, Neptune is too faint to be seen with the eye. And that's the only thing that would be relatively blue, but you need a telescope for that. So I suspect that maybe if it was just sitting there and set slowly, I suspect they probably saw Jupiter, but why it looked blue is a mystery to me. Usually it looks just sort of white to people.
Yeah. It's more than a fluorescent sort of white, you know? It's got like a blue tint to it.
Okay.
It's really weird.
And this was the eye.
Yeah,
Yeah.
I can see it right now. They actually filmed it with their smartphone, which is not a low-light phone, and it showed up pretty bright. And then she said, look, it's out there now. And I went out there, and it's like, probably the brightest thing in the sky.
Huh. But you know the difference between Jupiter and something else, so do you suspect it's actually something new?
Well, I know satellites more than I know planets.
Yeah.
The geostationary is not in that part of the sky. It is towards the equator,
Yeah.
But typically we only see those when the panels are rotating and they will flash.
Right, and they don't last very
Or
long.
if it were consistently lit, you would be able to take a delayed picture of it and see all the other stars streaking by it, but it's staying in the same place.
That's right. Yeah.
You know, so.
Huh. Okay, so
Yeah.
I would think. See, right here we were looking at the moon, and I believe. Yeah. See, I'm trying to still look at the moon, but unfortunately, it's gotten cloudy here, so we're unable to see more. So I was actually taking people through the Lunar Reconnaissance Orbiter Quick Map program, so they could learn how to explore the moon and stuff.
Well, that's cool.
Yeah, it's fun. You
Well,
know.
you're East Coast too, so I'd say probably maybe a couple hours ago you would have been able to see this.
Yeah.
Because we're in the mountain
Yeah. Yeah.
time right now.
Yeah. So I think that you probably. I'm gonna have to look. I'm gonna have to look and see what else might be there, because
Okay.
for all we know, hey,
Well,
look.
I'll see if I can get a video of it myself and get up
Yeah. close
enough to it that you can just see what kind of blue it is I'm talking about.
Sure, and it would actually be great if you could actually
What sky did you say?
put Jupiter in there too. You know,
Yeah.
if you can see
I
Jupiter.
don't think I can see it from where I'm at. I'd have to. It's pretty cold out.
Oh,
I'm filming this like through a tree.
okay. Well, I don't blame you, man.
Um,
Well, we endured some pretty chilly temperatures ourselves this past week, right? So, all right. Well, I'll check it out and let me see if I can come up with something for you.
Okay.
All right.
Thank you.
All right, man.
All right. Hey, we'll talk to you later.
All right. Have a good night.
All right.
Bye. All right. Well, yeah. So that was Ben Hansen.
Oh, you do have headphones in. I thought you took them out. That's why I was talking to try to get some answers from people. What sky did he say he saw that in?
In the southwest and
Southwest. Where's Vega right now?
north. Well, it's sort of in the northwest actually. It's the wrong side of the sky. I was thinking the same thing actually. So you know what we'll have to do, folks? We're gonna have to look and see. And Ben is a really, trust me, Ben's a pilot. Okay, he knows everything about the sky from an airline point of view and compass direction. So when he tells you a direction, it's dead on. You know it is. So I'll have to look and see if maybe there's a new, could have been a supernova, who knows, or just a mistaken identity of an airplane coming in on a long final to a runway, but the lights are usually orange, not blue, and Ben knows the difference hands down. So for him to ask means that it had to be something pretty odd. So that's pretty cool, huh?
Yeah. Yeah. So you said it was a southwest sky, you said?
Southwest. Yeah, and I know that southwest is
At
really
what time?
kind of right now, actually. So that was for us on the East Coast. That would have been about 3 hours ago.
Right.
And if you look at where Jupiter and Saturn are, Jupiter's supposed to be on the horizon. So what would be blue near Jupiter right now and Saturn? I thought they were pretty alone in the sky right now, so that's kind of interesting.
Yeah. Do you, I guess you don't have, stellarium. Oh yeah, you usually use stellarium with your telescope, don't you?
Of course. I have it.
Would have it open.
All right, well, let's go do it. Let's go bring it up.
Why not? Live research, people.
Live research, here we go.
It's done. We're either debunking or we're
You can
getting ready for an alien invasion.
You can just see the very edge of the moon there. It's really not too exciting, unfortunately. But not to worry. The clouds do seem to move once in a while. Oh, kind of howl. All right, stellarium. Let's increase the size of stellarium a little bit. There is the moon, and Jupiter and so forth are set, but we can go backwards in time just by doing this.
Yeah.
Now we're going backwards in time.
You could also change your, because you're set for Walcott, right? So you can also change it to his general area.
Yeah, I could indeed. But I just, because of the stars we're supposed to see. Wait a minute. He said
southwest.
Yeah,
Jupiter,
he said
Saturn.
southwest.
And it wouldn't be Altair. Altair's not that.
No, but
Vega.
Vega is sitting out there, but it's still 30 degrees above the horizon. They wouldn't make the mistake of that. And that's northwest.
You know what? Can you go to his general area just to see what his view was? Because I find that when I do that, the perspective that I think it is isn't always what I think it is. I'm
Agreed.
like, oh, well, this should look like this, or this should look like this. And
Yeah.
something doesn't.
Yeah, let's set up our location here.
Just a general area should do.
Yeah, that should be fine. Oops, hold on. Come on. We don't care about time. I want... Go away. Okay, here we go. Location window.
There you go.
Oh, let's pick...
Really set up this window better, this location window
I
better.
know.
It's kind of confusing. But, you know, once you're used to it, it's alright.
Okay.
So he's around Ogden, Utah?
Yeah, that's what I figure. He's actually... It's a different town.
And he said it was going on right about now, right?
Well, it'd be 3 hours ago from what we are now, right? And so right now the time here is 22:46, 10:46. So we're talking about something that was be 7:46. So we want to go ahead a little bit in time here. So that puts Jupiter near the horizon, like he said. Okay, so here we are. So this is the view from there. And southwest.
In the general area.
Could
And
it
did he
have
say
been
how far above?
Could have been Fomalhaut. I mean, that's Blue Star.
Right.
But that's not going to be it.
Yeah.
I don't think that's going to be it. See, this is live research, ladies and gentlemen.
Ladies and gentlemen, this is live research here. We're gonna look for things in the sky.
Interesting.
Yeah, zoom in a little bit. Okay, here we go. And he said it had a blue.
Yeah, it was a bright... He even saw it. It was very, very blue.
So bright blue.
Damn, if he saw a supernova and I didn't, I'm really going to be upset.
Yeah, right? That'd be awesome.
I'm really going to be upset.
Yeah, what could that have been? What is the little yellow mark next to Saturn? Is that something? Oh, you probably have.
That's a globular cluster. That's all. Measure 75.
But then again, the southwest, the way the sun's sitting, the way the Earth is tilted, could it have been, yeah, exactly, Carol. Could it have been a satellite trajectory coming toward? So it would almost have to be a, you know, because it would be catching the sunlight at that high enough up. It would be extremely.
I've actually seen satellites at midnight. You know, it depends on their altitude. But yeah, if it was a satellite, okay, satellites are only there for 2 minutes at the most, 3 minutes. Then they pass over you. And the geosynchronous satellites, as Ben said, I don't know if you heard that, they stay in the same spot in the sky, which is what he was thinking it could only be. But they do tend to flash if their panels tilt toward the Earth. And that flash could have been that color, and it could have been the blue of a satellite panel, of a solar panel on a satellite. But the flash would have to be a real direct flash. And they do wobble, they do tend to wobble. So I'd be really interested in knowing what this was.
Yeah.
Very cool.
Right.
You see, friends, my friends, we might not get to see the moon live, but we get to see weird stuff and hear from cool people. What can I say? Yeah, so that doesn't really tell us much, does it? Unfortunately. let's go back to our location here. I think I added this a while ago. I didn't, so I'll just do this. I'm close enough to locus, so this works.
That's cool. Yeah, Charles, I thought about that too, ISS, but I think the ISS path right now is over the east coast.
Yeah, Ben knows about the ISS hands down. He's really very knowledgeable about that.
And how long did he say it was visible for?
It has remained out there for some time so far. His mother saw it first, and then he went out to see it.
Okay, so like an iridium flare and stuff wouldn't be.
No,
Like not.
and iridium flares are no more, as they've deorbited the constellation, as they say.
What if he saw? I was trying to think about Starlink, but they're not going to run that direction.
Yeah.
Interesting.
In fact, Starlink. You know what? Starlink is how we're going to get internet out in the desert. You know.
Yeah. Yeah, I sent you a message about that actually.
You did? Oh, I think you did.
Well, last time we talked,
Okay.
we were talking Starlink and stuff, and I sent you kind of a inappropriate message with a lot of 4-letter words.
It may bother our astronomy, but it's the only way we're going to get to pass it on to everybody.
Yeah.
You know, much superior upload rate than here.
I believe what was said was, let me check our chat here.
Hey, we've got some miners in the audience.
Oh yeah, but I said, but yeah, if Starlink is going to beep boop with our skies, you might as well use it.
Yeah.
Or make use of it. So yeah.
We will be making use of it.
See, that's what me and Mark talk about when we're not on air. We talk about how things are beep boop
We will.
with our skies.
We will make use of things that even beep our skies and make beep and beep and I can't stand
For
beep.
anybody wondering what beep is, it starts with an F and ends with a P.
Hey, watch that.
Hey, I'm just giving them so they know what the beeps are.
The word is freak. Okay. This is our sky right now. I'm not surprised, but I'm also not pleased. So, let us try one more thing here. We're going to go back to our guy here and finish your last thing here.
Thank you, sir.
You wanted to see the size of this pit right here. What's the size of the pit? Here
You know,
can see.
while you do that, I'm going to run down your participants here and just say hi to everybody.
Oh,
just in
please
case.
do.
Why I keep trying to click your Skype window.
Yeah, I know, right?
Okay, here we go. Let me go back here. Top chat. Should I just run through the chat because usually they don't.
Yeah, the
participants.
yeah.
If you haven't posted in a while, which kind of actually I'll give people a chance. If you're hanging out with us, even if you're not in the chat, just say hi or something, and we'll shout you out in the chat and thank everybody for hanging out with us. Because right now it only has 4 people as participants, and there's 30, 31, 29. Yeah, so we're hovering around 30 people watching. Mark, I was going to tell you this. We're going to do. We'll pretty much know by tomorrow morning or tomorrow afternoon if we're going to have a pretty clear night, and if so, I'm going to put a lot of messaging out to people.
Okay.
So we're going to have a pretty big crowd tomorrow night. I'm pretty sure.
I hope so, and I look forward to joining you.
So yeah, if you guys are listening and you just want to say hi in the chat real quick, that way we don't miss you. If you don't, that's quite all right as well. Thanks for joining us, everybody. We're checking out the LRO quick map because our moon kind of got clouded out, and it's myself, Keith from P&K Space Imaging, hanging out with Mark D'Antonio on his channel.
We are streaming on SkyTour LiveStream.
SkyTour.
This is SkyTour LiveStream East right now, and West, the observatory is finished. The roof rolls on and off just beautifully, thanks to Marianne Robb and Tara out there, who's been just amazing in getting these things to work.
Wow, a bunch of thanks to Marianne.
Yeah,
for everything
she's a superstar, rock
Yeah.
star.
Yeah. Yeah, that's, just from what you explained to me, and I don't even know the whole situation, but from what you have explained to me and told me about, she has been a massive, massive help.
Yeah. Yep.
I guess without her, the SkyTour West wouldn't even be going on.
It wouldn't.
Yeah. So, major thanks to Marianne. I haven't seen her in here yet tonight, but I'm pretty sure she might pop in. Maybe not, but if she listens back later.
No, I think that she may have gone to bed because she is a police officer.
Yep.
And she goes to bed like really early.
All right, so running down the participant list real quick. Of course, we got Carol.
Carol.
Yep. And we got Daisy and Zoe, and we got Doug, Do W, and E Matt, and and Rascally Rabbit, and Tim Elf, and Weird Guy, and
Terry Groff. Daisy and Zoe Amethyst.
So we'll keep letting that thing build up a little bit. I'm not sure if Siobhan's still listening, but Siobhan as well. People that were here earlier. Let me just run up the thing.
Charles
But anyway,
Smar.
people that aren't talking. Thanks for joining us tonight as we hang out.
Rockstar.
Rockstar, yep, that's another one.
Yep.
And Charles and
Papa Tom, who had to leave.
So, with that being said, Renee Cruz.
One of the first ones here was Renee. She was actually the first one tonight.
We almost forgot about Q.
And Q was here, yeah.
Yeah, what do you guys want to see in the LRO?
And DPFX 999999.
Is there anything you guys want to go to and check out? Because I remember anybody from the P&K stream remember the big crater with the gun in it, with the giant laser gun.
David Byrne is here.
Everybody said it looked like a big laser. Maybe we can check that out.
Don Walker was here.
Hey, Don Walker. Isabella, good one.
Isabella Melamed.
Yeah. So I think we pretty much got everybody.
Yeah.
If not, we'll do another one later.
That's all right. I'm wondering whether we should basically say we're done for tonight because we don't have a moon. You know, and in the absence of any other information, I guess that works, right?
Right.
Yeah. By the way, your little ridge here is 0.7 kilometers across. See that? The Cobra head?
We've been on for 2.5 hours already?
Yes, we have 2 hours, 24 minutes, and 53 seconds mark.
Okay, Do wants to know, we did do some Apollo landing sites earlier, but I'm pretty sure Mark can find some real quick just to show you once again. And anybody else, before Mark decides to run away and leave us, any places you want to go with the LRO, put them in the chat. We'll jump across and start jumping around the places for you guys to see them up close and personal if you never have.
Here, here's another place to show you right here. This is, you can just barely see it. When the Russians landed on the moon, they actually went to several places. This is Luna 17 rather. And if we get down close enough to the moon, we might be in one section of data that wasn't fully resolved. So we're in a tiny strip that is not as resolved. But we back out, and we also have Lunar 1. And this should be better. Let's see if we get it. Okay. Yeah, this is an area of low quality data. It's being updated all the time and upgraded all the time. These are called anthropogenic features. Those are features created by humans. Okay. This is the Chinese lander, Chang 3, and the U2 rover. And as we make our way into this, I think we can come in here and see a little better. Yeah, there's just not good data here either. It's becoming a thing.
Conspiracy.
Yeah, but that's what those are. And that was on Chang 3 was on the near side, not the far side. It was actually just below Plato. And then let's see over here. Oh, remember the Barren Sheet? This is the Barren Sheet lander. Didn't that crash? Didn't Barren Sheet crash?
Right.
I believe it did.
Hey, there wasn't anything left of the L cross, right? Once they crashed it in, it pretty much just
Yeah.
canned itself. Yeah.
Oh, wait a minute. Are we actually in the 3D moon?
I don't think so, actually. But
Oh, yeah, we are. That's okay. Let's change and go to orthographic near side. We might get better data this way. Let's
Hey,
try that.
China land their rover at?
Well, we just went by there with the Chang 3.
That was the recent one, right? Chang 3?
Yeah.
Oh, that's right. Didn't they just send one like a couple days ago?
I don't remember. Oh, look, Barren Sheet. Here's the crash site. Look at. You can see the crash site here. Oh, that was too bad. Can you see how the this is where it crashed, and it has this dark scar. It wasn't supposed to crash. It's too bad it crashed. Okay, and let's pull out of here for a minute. Let's do our Pilates and get out of here. And let's try to find. Right, this is Luna 21. This is another Russian project.
Once again, guys, if you want to see any craters or anything like that, post them in the chat so we can get there for you before we wrap up.
Yeah, there's Luna 21. You can see the bright spot there of Luna 21 on the moon. See, it's not just us.
It's not just us.
A lot of nations have made it to the moon.
And credit to these nations for giving data, and of course, NASA's probably tracking it all the time.
They were, but it doesn't matter.
Yeah. I mean, cooperation like this for data and data fields, even with China, them giving up their photographic data, and stuff like that. It's starting to come into a global thing. Of course, everybody right now is going towards the moon for their own benefit, but I do think we will eventually round that corner to where it is a human exploration
endeavor. Yes, all humanity. Here is Apollo 17, and there's a lot we can see in this one. Okay, this is the lunar module, the Apollo 17. Let me just get this out of the way for a minute.
That is awesome, huh?
Here's the lunar module. Yep. Here's some experimental packages left behind.
HUH.
Yeah.
That's awesome. Only Mark can get me to open my laptop to see this. I use my phone for YouTube and otherwise. And so hopefully, maybe you'll give us a chance tomorrow night. Hopefully, if we stream, and we'll have Mark over there, and we'll do some scoping.
Yep. There's the lunar rover for the Apollo 17 right there.
Yeah. Look at that thing.
Yeah, they actually went quite a distance with Apollo 17. They went all the way down around this crater, and
they went exploring.
Yeah, they did. They went exploring. I mean, there's other views where you can actually see the path they took. It's really cool. And then let's see. Now.
The one with the pyramid. Let me think, because there's a lot that looks like that has a pyramid in it.
You're not talking Mars.
No. I was talking to the guys in chat.
Okay.
I want to see. He said, weird guy said, I don't know the name, but the one with the pyramid Paul always went to. And I'm trying to remember the name of that crater.
Oh.
So it'll be towards the first quarter. And it'll be towards the south of the side of the moon. So that narrows it down a little bit.
Now, before we actually landed on the moon with lunar modules, we crashed on the moon quite a bit, and the Ranger program was one of those where we did that. This is an artificial crater created by the crash of Ranger 6. Let me make sure that's the crater. Yep. This is the Ranger 6 crater created by the crash of the satellite. They ran it into the moon at high speed. Kaboom! And they took the data from the crash, and we got a new crater out of it.
As I said, all data is good data, even when it's crashing.
That's correct.
Yeah.
You have spoken wisely. Yep. And then we have other... Okay, there's Apollo 16's landing site. Okay, and if we look, this is the lunar rover. Sorry, that's the lunar rover, lunar module, and the ALSEP experiments. Those are the primary experiments. So, okay, we have the lunar rover is right here. It's hard to see. Trails, descent stage, and then more trails out to the ALSEP. And you can see more trails here that go all over the place. Really quite an excursion that they went on, you know?
Oh, yeah.
They racked up a bunch of miles, let me tell you. And they got frequent rover miles. Okay, so let's back out of this guy. And as we back out more.
I think that crater might have been called Eratosthenes, but I'm not sure.
Eratosthenes?
Yeah.
Hmm.
I don't think that's the one with the pyramid. For some reason, it's popping.
Okay. You're not talking about Pythagoras and the gun, are you?
No, but Pythagoras would be really awesome to look at if anybody knows from the streams. When you get that certain light that hits it, it looks like a big laser gun in the middle of a crater just because of the angle.
Laser.
That would be awesome to look at on the LRO, what it actually looks like.
Oh, yeah. And now here, this is the Apollo 11 site. This is our first landing on the moon. And there is the descent stage for Apollo 11 right there with its attendant shadow. Okay? You can see the track. I mean, when they walked on the moon, they actually had a little cart that they towed behind them with stuff on it. And so you can see they didn't go very far. Compared to the Apollo 17, where they went miles with the rovers, you know. Now you see there's Apollo 11. We stayed for a little while, got back in our car, and went home. But that's Apollo 11 right there. So it's pretty interesting.
Guys, think about the age we live in. We're sitting here looking at the moon surface from the comfy of our homes.
Mm-hmm.
The amount of technological advancement in the last 50 years.
Oh, yeah.
You know, we are streaming astronomy to people.
Yep, that's right.
It's really amazing, and when you really think about how far technology has come in the last 50 to 100 years, it just exploded, and even in the last 10 years.
Oh yeah, without a doubt.
And if we keep going like this, it's either going to be really scary or really beneficial, depending on what we as humans do.
I'm thinking it's going to be pretty good.
I think so too. I'm optimistic.
Yep.
You know.
So here's the Apollo 14 lunar module and the attendant experiments over there. I'll show you those now. You'll see the shadow of the Apollo 14 right there, the Apollo 14 descent stage right here. And they're square because the top is flat. It's a square, basically a square object with a flat top, because that's the descent stage. And then we see this tracks out here. Okay, all the way out to the lunar experiments that were left here. Okay. And then we have Apollo 12. Let's go there. Okay. And if we go zooming down, look how close you have to get to actually see something that's human-made. Okay, we're already closer than most telescopes. Now we're closer than any telescope from the Earth can get us.
Oh, yeah.
All right, and now we come down, and we have to do this. Look at that. So now we can just remove, and you can see the descent stage here very clearly.
Apollo 12, that was the Conrad and Bean mission, right?
Correct.
Yeah.
I knew Alan Bean. He was a great guy.
And who was the guy in orbit?
Michael Collins? No. Was it Collins? Who was it?
Apollo 12 was Gordon, I think.
Yeah.
Dick
Well, Alan Bean was in the surface though.
Yes.
For 12.
Yeah, Bean, I think, was the lunar module pilot.
Mm-hmm.
And then I think Dick Gordon was the command module.
Okay.
But, I could be wrong. Don't fact check me.
It's all right. But check this out. Watch this. From Apollo 12, look at this. Look at this. Keep looking, keep looking, keep looking. See the track? Keep looking. All the way out. Keep looking. Yeah, we decided to go quite a distance. You know?
By the way, if anybody ever reads up on Apollo 12, it's a pretty amazing trip. They had to do a really precise landing for Apollo 12.
Yeah.
Because they had to get in. Was it a? No, it wasn't a satellite. It was like a probe or something that they had to get darn close to. Because they wanted to be within distance to get to it.
Was it the Surveyor you're talking about?
Yes, Surveyor 3.
Was that Apollo 12?
Yep. I believe so.
Okay, well, I gotta check that out because
don't quote me, but I believe Apollo 12, yeah, because they had to get within, they wanted to, well, from what was said, like in the books and stuff, they wanted to be within like walking distance, or like within.
And they were.
Yeah, they did a really, really, really precise landing of that thing, and I remember reading a couple stories about it.
Because I went out to Apollo 12 site here, and I think. Okay, here's the Apollo 12. Yeah, this is the one. Because look, and the weird thing is, this is the Surveyor that they landed at. Okay, here's the tracks around the crater that they made to get to it. Okay,
yeah.
And they took a photo down here in the hole. Here's Surveyor. I think it was Surveyor 3 or something.
I'm pretty sure Surveyor 3 was Apollo 12.
Okay. Well, they ended up taking a picture here. This is a crater, and for proof, all we have to do is do our little experiment here. Draw this and go across to this.
By the way, I will say another funny story about that Apollo 12 mission. I believe that's the one where they spent all this money to send a color camera up to the moon, and it got ruined because was it Bean or was it? It might have been Conrad. One of those guys pointed it at the sun and destroyed it accidentally.
Oh, bad move.
So they made this big deal about taking this color camera up there, and then they pointed at the sun and it also feeding, and it was over. So if you had a bad day at work, at least you didn't destroy
a multi-million-dollar camera.
Yeah, exactly. But yeah, if you get a chance to read up on Apollo 12, definitely do it.
It's a really good mission.
Especially if you can get the autobiography kind of it. I think it was Gordon. I think I was reading the one that Gordon.
Okay.
Somebody, how they write with people.
Yeah.
Like stories, and then somebody transcribed it.
Co-authored with.
Exactly. Yeah, but it's really really good.
Yeah. So the earlier Surveyor mission landed in this crater. That was an unmanned mission, but a soft landing, and it took lots of cool pictures. And they landed the lunar module here. They went around this crater and then walked down into the crater and retrieved a piece of the Surveyor to bring back. I thought that was pretty cool. I don't remember what they took back. I don't remember, but there's a famous photo showing an astronaut touching the Surveyor with the lunar module on the ridge in the distance. It's really beautiful shot.
They took off some parts of Surveyor and actually returned them to Earth.
Yeah, that's what I was saying. I wasn't sure what they took though.
Yeah, I think it was just some parts that.
Charles says silver batteries.
Was that what it was?
Yeah.
Nice.
Yeah. Thank you, Carol. What a wonderful little summary you gave us. Thank you. So that's the Apollo 12 mission, and so Apollo 13, of course, never made it. But there is something of Apollo 13 on the moon. If I recall, and I want to see if we can find it, and here it is. See, when they went around the moon with the lunar module and the astronauts in the command module, and they had to jettisoned the stage that held the lunar module, and that was the Saturn 4B stage. And they jettisoned it, and this is the crater it made on the moon when it hit the moon. And you can see, once again, you can see a streak going this way, that way. There's a little one going this way too. And it could have been because it was rotating, but you can actually see that it's the cylindrical stage. You can actually see it in the crater, crushed flat on impact. And that's the crater it made, in that soft dust. So that's the only part of Apollo 13 that made it to the moon.
Yeah.
Yep. They came back to the Earth and survived, but they rode back quite a distance by using the lunar module as a lifeboat. And when they finally got into the Earth orbit again, they jettisoned the lunar module and burned up in the atmosphere. If I recall, actually, I think that's the only way it could have happened.
Yeah, there are epic stories for each Apollo.
Oh, there are.
You know, it's just, if you read in depth with them, they're just
Yeah.
scary, exciting.
Oh, I know.
Path forging.
Yep.
Even the smallest of
Pioneers.
You know, how the smallest of things that we kind of take for granted here on Earth. You know, there's no lifeboat out there.
Mm-mm.
You know, something goes wrong, it's gonna go wrong bad.
That's right.
You know,
That's right. Mm-hmm.
we listen to these guys' stories of every little thing, and actually some of the things they did, you know, to repair stuff and things they used. They went full MacGyver sometimes. It's just it's amazing that you had those kind of people with those kind of minds, willing, you know, thinking on their feet, and it's amazing.
And think about this too. And I've been checking our view, guys, and it's just sad.
Look at that beautiful moon.
Yeah.
Hey, we tried.
We tried, but you know what? One of the things I've discovered is that it may not always go to plan, but sometimes when it doesn't go to plan, it still is fun. And so tonight we got to look at this Lunar Reconnaissance Orbiter stuff. Remember, it's the Lunar Reconnaissance Orbiter Quick Map. That you don't have to spell it out. Just say LRO Quick Map. That's Quick Map, all one word.
And I'm pretty sure one of our beautiful mods in the chat there will post a link for people if they want to check it out themselves. But beware, if you do start checking it out, you might be up for a while.
You might not go to sleep very soon.
It's amazing.
Because you can zoom in on all these different places and you're going to go, wow, how can we possibly do that?
Stuff like the LRO site, that's your tax dollars at work, and they have done a wonderful job.
Oh, yes, they have. They have. I know the guys I've been doing stuff with the folks that actually take care of this data, and here's the link, by the way, in the map and the thing here in the chat. And they got me data as well for the moon that's just unparalleled. You know, it's all stuff paid for with our tax dollars, man.
And just a reminder, if anybody wants a 3D printed moon crater, our friend Mark here does that as well.
Oh, I make whole moons now.
And he has those full moons now, and I have many of the craters.
I have a round 2.5-inch moon that we make, which is, I did it on an SLA machine, and you have every single crater, almost every crater, every major crater on the moon in beautiful, beautiful resolution.
Yep.
It's so
I
different.
can't attest to that because I don't have one. So.
Yeah, well, you know, I have to make a mold and make copies of that, so you can.
Yeah, exactly.
Yeah.
We'll have to get together sometime soon again, because I think the last time I seen you was what, was it? No, yeah, it was what, May last year? 2019?
Pine Bush?
I believe so.
Yeah.
Wow.
I was in Pine Bush several times over the last 2 weeks, too.
Oh, yeah.
Yeah. That's 2 hours, 2.5 hours from here. But we were based in a hotel in Danbury, so it made it easier.
Yeah.
Well, Well, folks, we're going to say goodnight to the moon tonight because the moon has said goodnight to us. But I do want to thank you for coming on out. I mean, I really had a good time with you guys. I'm really glad Keith could join us. Thank you, Keith. That's very wonderful of you to come along.
Not a problem.
You're the man. You're the man. You know, we always enjoy your attention. Actually, you know what I'll do? Before we go, let's rotate around the backside of the moon and see if we can find any missions to the backside that might be here. I don't know if there are any.
While Mark is doing that, I will remind people, SkyTour Radio.
Oh, yeah.
KGRA, Sunday nights, 8 to 10. And once again, you can see Mark on TV, every channel you turn on. It's
Stop.
Every time he pops up, still is weird. You know?
I'm sorry, it's weird.
I'm sitting there, I'm like, I'm watching, NASA's Unexplained Files. I totally forget that you're on that. And the next thing I hear your voice, and I'm like, uh-oh.
Can't get away.
And there he is. But it's great.
Sorry.
And I can't wait to see the new stuff you're working on as well.
Oh, this is pretty cool. Actually, it's really neat. It was a neat show. And like I said, I hope it goes further.
I seen your Facebook post, and you definitely did a bit of a cliffhanger there.
I didn't mean to. I just didn't have words. I still don't. I had some things happen to me that I just don't know how to explain.
So when are you able to disclose these stories once it airs?
I didn't do that because of that, but I did it using it because of an abundance of caution. I got to be careful because I'm not sure what I can really say.
Right.
And that's part of the problem. It's always a silly issue. It's always an issue. It comes with the territory, I guess. But I did have some experiences that me, Mr. Science Guy here, I couldn't explain. And
that's great, isn't it?
Absolutely. I'll take a polygraph. I'll take whatever you want me to take. Okay.
But isn't it great? Like when you have that scientific mind and something like piques your interest to the point where either you can't explain it or you don't have a rational explanation for something, all of a sudden the mind starts racing. My
mind started racing, but I was also trying to solve the problem. What was going on? Why was this happening to me? Why is this going on right now? And some of them were urgent, as in potentially threatening.
Yeah.
And as soon as I exited the situation, it immediately stopped. I came back in, and it was immediately there again.
It seems I'm going to have to come with you on some of these trips. You need somebody to carry your bags or something?
I think that you'd probably be perfect for this. I actually got mad because this was happening, and I kind of got confrontational with what was going on. And
get confrontational, I'll slap you.
Of course, I got no responses, so it was really strange, and I'm just happy that I got out of it with my skin intact, because it didn't.
Senses, right?
I had a problem that I can't explain.
Yeah.
Okay, here's the Chang 4. Here's the Chinese Chang 4. Where'd it go? There it is. Alright, well, this is where Chang 4 landed. It doesn't show you. Oh, you can't see it. Duh. Here we go. This is where it says Chang 4 landed. I'll show you. It says it landed there. Okay, we just had to wait for it to...
I heard about Chang 4. I believe it was launched in January of 2019.
Okay.
It is a...
holy cow.
It was a robotic lunar explorer, I think.
Yeah, it was. Yep, it was. Yep. And there it is, right there. And, of course, we're using a 3D moon here, so... we can go in as far as we want, but it doesn't help us because we quickly get past the resolution. But you see that?
Yeah, but that Chang 4 was supposed to do some like crazy stuff, right? So, and I haven't been keeping up with it. I should actually read up on it a little bit, but they were supposed to be measuring like chemical compositions and stuff.
Yeah.
In the rocks, and then like, 'cause what we were talking about earlier, like, wasn't it going to like study like the sun's rays and how it affects the surface?
Yeah. Well, keep in mind, the thing to keep in mind is that every part of the moon gets illuminated by the sun except for those craters that are in permanent shadow. So what we call, and have traditionally called, the dark side of the moon is not ever fully dark. It has as much sun as the side we see. It's just that when it's a new moon and we don't have a moon or a waning crescent or a waxing crescent, the other side of the moon is lit right up by the sun. So, and you know that, of course, and most people do know that. But there's a reason that the moon is tidally locked to us, and that's something that we don't.
I'll give you a rare thing about the Chang 4 as well, that it was sent to the moon, it landed on the moon, but one of its missions had nothing to do with the moon. It was actually studying the sun.
Ah.
But a better place to do that is someplace without an atmosphere.
That's correct.
And it was, hold on, let me look it up real quick. It was to observe the solar corona, investigate its radiation characteristics and mechanism, and explore the evolution and transport of coronal mass ejections between the sun and the earth. So once again, you always have these two doing a dance in the sky. You have the moon and the sun always doing this dance. They always seem to be connected somehow.
Yeah.
Norse mythology, you had Mani and was it Sol, I guess? Yeah. With the moon and the sun. They were always linked.
Yeah.
I
Absolutely.
love Norse mythology too, so I've been reading up a lot on that lately.
No, I was over there for half of August last year, right?
You lucky duck.
Yeah.
I'll get there.
Oh, it's a beautiful place. Actually, if you want to have some fun, look up Rail, as in R-A-I-L, Cow, as in C-O-W, and then Girl. Rail, Cow, Girl, and ride the Bergen Line in Norway.
Yeah.
It's really beautiful.
One of my favorite poems ever was actually transcribed. I don't know if anybody here knows Norse mythology or not, but there's a poem called the Veluspa, and it's basically it includes the sun and the moon and stuff, and basically it talks about, anybody that's know Marvel know these people that I'm talking about, but it's basically the history of the universe, and it tells a story of like the future of the god Odin. It's a really good poem. There's a lot of really good Old Norse poems and stuff that you should really check out. If I may recommend anything, anybody that's into that stuff anyway.
You are more than welcome to recommend away.
Yeah.
Very cool. I'm very much interested in that stuff, and I have managed to learn a good deal of it over the last year or so. So it's pretty cool,
I just actually got a new book. I wonder if you ever read it, Mark.
What is it?
It's called, basically it's by a guy named Likatu, and it's basically the Encyclopedia of Norse and Germanic Folklore, Mythology, and Magic. And it's actually really good because it's an explanation book, not a storybook per se. So it gives you the explanations of a lot of Norse stuff and Germanic folklore and whatnot. It's a really good book.
Ah, interesting.
Likatu.
Carol Carl says that you can carry my bags, but she'll carry yours.
Deal. My bags are heavy. I pack cameras.
I know, right? And telescopes.
Telescopes, cameras, laptops.
Yep. Exactly. So, number one.
Bring your back brace.
That's it. Wow. All right. Well, you know what? Our moon has not been cooperating with us, guys. So I guess what we'll do is we'll just shut down the stream for tonight. But I want to thank you guys for coming. We had a good time. Keith, thank you for joining me.
No problem.
And you guys, you've been a lot of fun to have with us tonight. Thank you so much for coming out.
Oh, and once again, P&K tomorrow night, hopefully with Mark. If the weather is good,
Yeah.
We return tomorrow, Wednesday.
And that's been the first time in how many months? 4?
4, just about 5.
Wow.
So,
All right.
Yeah. So tomorrow night,
All right.
November 25th. Hopefully, we'll get a good break.
Isn't that Thanksgiving?
What? Well, no. Today's the 24th. 25th is tomorrow, which is Wednesday. 26th is Thanksgiving.
Oh, okay. Okay. Thank you.
Yeah. We're doing the night before Thanksgiving when everybody's supposed to be drunk in the bars.
Yeah, you got it.
They're not going to be. So they'll be home and hopefully chilling with us.
Mhm.
So hopefully we'll see you all there as well.
All right. Well, guys, thanks for coming, and I will talk to you another time, actually soon enough. Really enjoyed your company. Hope you enjoyed our little, foray into the only place we could go tonight, and that was the Lunar Reconnaissance Orbiter Quick Map World. So I appreciate your attention, and I will definitely be back on the next clear night, along with someone else. We'll probably have Daryl with us next time, and probably Amanda maybe. So we're gonna make sure that we get back to you. So you guys have a good night, and we will talk to you on the downside. See you later. And then there's that.
Good night, guys.
Gosh, that's Keith. What can we say?